He is a fellow of Indian National Academy of Engineering, Indian National Science Academy, Indian Academy of Sciences, IEEE USA, and Indian Speech Communications Association. He was a distinguished professor at IIT Hyderabad during the period 2020 to 2023. He is an adjunct faculty at IIT Tirupati and distinguished adjunct professor at IIIT Naya Raipur. He is the recipient of several awards. We welcome you, sir. It's our pleasure to welcome Dr. M. Sridevi, Professor and Head, Department of CSE Data Science, Anurag University, and convener of this conference, to come on to the dais.
Dr. Sridevi has over 20 years of teaching experience in academia. She has completed PhD in Computer Science and Engineering from JNTU Hyderabad. Her research expertise includes information retrieval, recommender systems, data mining, and machine learning. She has published around 20 papers in international journals and conferences. She is a recipient of Best Teacher Award. We welcome you, ma'am. I request Dr. G. Balakrishna, Assistant Professor, CSE Department, to come on to the dais.
Dr. G. Balakrishna has 15 years of teaching experience. He has published over 15 research papers in international journals and conferences. He is serving as active reviewer of peer-reviewed journals such as IEEE Access and InterScience. We welcome you, sir.
Our chairman, sir, Dr. Palla Rajeshwar Reddy, and Secretary Neelima ma'am will be joining the session shortly.
Lighting the lamp signifies the dispelling of the darkness and igniting of thought and enlightenment. We invite the dignitaries on the stage to do the honors. Mrs. Ashwini Sharma to render the prayer song.
Vandanam Sharade, Vandanam Visharade, Vandanam Sharade, Vandanam Visharade, Sharade Visharade, Sharade Visharade, Vandanam Sharade. Veena pustakadharini, Vidya buddhi pradayini. Veena pustakadharini, Vidya buddhi pradayini. Svetambaravaradharini, Shrivani namostute. Shvetambaravaradharini, Shrivani namostute. Vandanam Sharade. He Hamsavahini, Satya Vimala Swarupini. He Hamsavahini, Satya Vimala Swarupini. Nitya Niranjanakarini, Shrivani namostute. Nitya Niranjanakarini, Shrivani namostute. Vandanam Sharade, Vandanam Visharade, Vandanam Sharade.
Thank you all.
I invite Dr. M. Sridevi, convener, ICACII 2023, to share the details of conference.
I request Professor Muthareddy sir to grace the dais. Dean examination, please sir. Honorable members on the dais, respected Chancellor, Dr. U.B. Desai, Honorable Vice Chancellor, Professor S. Ramchandram sir, respected Madam Sameen Fatima, former Registrar, Anurag University, General Chair, Dr. V. Vijay Kumar sir, Dean, School of Engineering, Program Chair, Dr. G. Vishnumurthy sir, Dean, CSE, and today's guest of honor, Dr. Vishnu S. Pendyala, Mr. Pratyush, and our esteemed chief guest, Professor B. Yagnanarayana sir, co-convener Balakrishna. Distinguished speakers, scholars, delegates, faculty, and my dear students, a very good morning. As the convener of this significant event, I am honored to welcome you all to the second International Conference on Advances in Computational Intelligence and Informatics. After the successful completion of first international conference, the Department of CSE is organizing the second international conference, ICACII 2023. The theme of this conference encapsulates the latest developments in the theory, methodology, applications, and pressing challenges of computational intelligence. We have 5 tracks that includes artificial intelligence and machine learning, data-centric approaches, Internet of Things, high-performance computing, and computer networks and cybersecurity. We received 220 papers across 11 countries through EasyChair. All the papers are peer-reviewed and thoroughly evaluated by 120 potential reviewers at 3 different levels. Total of 44 papers are accepted and are to be presented within these 2 days. The papers that are registered and presented will be submitted for publication in Springer series. We had a 2-day pre-conference workshop on 5 different tracks from academicians and industry experts to provide a practical learning environment from which 550 UG students have benefited. Over the next 2 days, we will engage in informative sessions from the eminent keynote speakers, insightful discussions among the researchers and academicians through track-wise paper presentations, poster sessions, build our network, and make meaningful contribution to our respective fields. I extend my heartfelt gratitude to all the esteemed guests, especially our mentor, Dr. C.R. Rao sir, participants, organizing committee, sponsors, and all those who have contributed for the event to happen. As we mark the beginning of this journey, let us collaborate, share our journey, and learn from one another. Thank you, and I wish you all a productive and inspiring conference ahead. Thank you.
Thank you, ma'am, for providing the summary of the conference. Now I welcome Dr. G. Vishnumurthy, Dean CSE, Anurag University, to address the gathering.
A very good morning to all. Sri Gurubhyo Namaha. Honorable Chairman, our source of inspiration, Dr. Palla Rajeshwar Reddy, high-minded Mrs. S. Neelima, CEO, Professor U.B. Desai, a person par excellence, Chancellor, virtuous Professor S. Ramchandram, Vice Chancellor, writers Dr. U. Balaji, Registrar, splendid Dr. S. Sameen Fatima, former Registrar, my guide and mentor, Dr. V. Vijay Kumar, my colleagues, Professor M. Sridevi, Professor Balakrishna, convener and co-conveners, remarkable guest of honor for today's inaugural function, Dr. Vishnu S. Pandala, Academic Senator, San Jose University, USA, the illustrious guest of honor, Mr. Pratyush Nutalapati, Managing Director, Deloitte, eminent and exemplary chief guest of today's inaugural function, Professor B. Narayana, Emeritus Professor, IIIT, respected keynote speakers, session chairs, deans, heads of other departments, my colleagues, student volunteers, the researchers from Anurag University and the researchers from the other institutions, present media. A very good morning to all. A very good morning to all. Good morning, sir. Let me begin by saying thanks to the key people who are behind making this program to happen today, because it's not easy to host a conference. The actual thought process has to begin to host a conference 1.5 years before, because that is where we need to send a proposal to the publishing agency. So we are happy the Springer has accepted to be the publishing partner for this particular conference. So it will have 1.5 year effort to put in to have the program on this stage today. So we thank the invisible souls behind this program, Professor C. Raghavendra Rao, Central University, Hyderabad, Professor Salman Moise, who just entered into the hall from University of Hyderabad. So who really guided us to go through, effectively perform the review process and selection of papers and all. We sincerely thank our editors, Dr. Sandeep Singh Rawat from Indira Gandhi National Open University, and Professor Salvatore De Stefano from University of Messina, Italy. And very important, the reviewers who have done a Herculean task of reviewing 247 papers, finally culminating to 44 papers. It was not a simple task. Because they are the invisible people, nobody sees their effort. Only you will be able to see people sitting on the dais. But to have this program on this stage, these people worked a lot. So in addition to this, the entire crew of Department of CSE, who put their heart and soul, flesh and blood to make this program to happen in a grandeur. So you can see how they made the arrangements. So coming to the brief about Anurag University. The Anurag University is one of the finest upcoming universities in India from the state of Telangana, which runs various schools. School of Engineering, the Department of CSE belongs to it, hosting this conference. School of Pharmacy, School of Management, School of Agriculture, School of Nursing, Nilima Institute of Medical Sciences. So which makes a true multidisciplinary university, leaving a pathway for multidisciplinary approach. So far, the research was referring to some others' data sets. Now we can have our own data sets. So the School of Engineering demonstrated unbeatable history in the academic world. That is demonstrated through the accreditation for all eligible UG programs of engineering under Tier 1. It was received 140 rank in engineering category by NIRF, which stood in 25 to 50 band in the innovation rankings under Atal rankings. So we at Anurag University practice lot of best practices which helped us within the journey of 2+ decades. We could transform ourselves to CVSR College, to Anurag Group of Institutions, to Anurag University. The major change that is in place is the outcome-based education with a focus on student-centered learning, bringing a lot of effective learning practices into the system to the extent it's not only focused on the students, we also focus on training, enablement, practice and implementation of these teaching learning practices by the faculty members. To bring few initiatives to your notice, we entered an MOU with Aalborg University, Denmark, which is running a UNICEF-funded center focused on project-based learning. Almost 71% of the faculty members completed the 2 basic courses of what is P2BL. They call P2BL, that is problem project based learning. It cannot be always project based, it can be problem based also. So they call it P2BL. So this completed 2 courses, one focused on what is P2BL. The second one is where the major faculty members do mistake, that is formulation of the problem. Because the University of Aalborg says the problem has to be seen as a solution. Okay, it has to be an innovative solution. It has to be looked from that angle. So they train us how to formulate a problem, because Jones says formulation of problem is a very critical task. If you are able to formulate the problem properly, 70% of solution is in your hand. So all the faculty members were trained, and almost every semester they implement at least one course in their particular department. Now today we have a specialized project-based learning center which bagged very recently the Innovation Award in the conference which is going to held in the January International Conference on Transformations in Engineering Education at Hubli. So we also started putting a lot of focus on design thinking, because when the solution is developed, we need to be empathized towards the end customer. So we signed an MOU with a center focused on design thinking at IIITH, and all the faculty members were trained. Very recently, we conducted a 5-day program to understand what tools to be used for effective implementation of the design thinking. In addition to the teaching learning process we do at classroom, even the assessment pattern also we moved from traditional to effective learning systems. That is, the weightage has moved 50 marks for the continuous internal evaluation, where the project-based learning, problem-based learning, and effective teaching learning mechanisms like presentation, building prototype, developing a project, solving a case study plays a role. To support this, we also have a strong industry immersion. To say few, I am not going with the complete list. Amazon Web Services, AWS Academy, VMware Academy, IBM Skill Build Program, Infosys Springboard, Salesforce Trailblazer Initiative, Cisco Network Academy is the few initiatives to support the classroom learning to get certifications which are valued by the industry. In addition to this, we are also inculcating the research into the minds of the students and encouraging the students, 15% of the student projects to get published as the papers. For this, we have taken a mobile-based, web-based access of library resources by using mile off. Along with these few initiatives from the universities to support the ideation from the faculty, from the students with a seeding fund. So to inculcate the research culture among the staff, they have come with the seeding scheme for innovative projects by the students as well as the faculty members, sponsoring the faculty members to attend international conferences, to give the lion's share portion of whatever the consultancy activities they are doing, and also helping them by providing financial support in completing the executive courses. Apart from all this, because all the professional chapters strongly convey the professional students must have an ability of self-learning. So we have a lot of opportunity for the self-learning in terms of professional chapters, in terms of technical clubs, in terms of giving the chance for them to host the various non-technical events also, and to bring to the, because we have the guest of honor from Deloitte and the dais. So a few years back, along with our honorable chairman, we visited Deloitte to understand what are all their expectations from the graduate students. So when we had interaction with Mr. Vikas Gupta, who was the managing director, talent, so he told, you have proofs for convey that your students are good in technical, so you have certifications. But how you will communicate that your students are good in communications? Then he has given the two ideas there. One is to start big certification program, integrate that with the curriculum. The second, to start the Toastmasters Club. So we started that, sir. Thank you for the Deloitte indirectly. That is helping the students to improve leadership qualities as well as the communication skills. So along with all this, we are also providing opportunity to the students to have the wonderful learning like experiential learning and community-based learning by linking these two, the community reach through NCC, NSS, Engineering Without Border chapters. In addition to this, the consistent academic result, consistent placement of the department made the department of CSE, especially BTech Computer Science program, as the first sort among the students. So coming to the philosophy of the conference, because now we are doing so many initiatives encouraging the students to go for publication. So we thought of moving a level above. So how to move a level above? And the experience of executing this first international conference in 2019. So we understood the culture need to be fostered, nurtured, encouraged. So these are the 3 steps need to be done continuously if you want to have the research progress in the campus. So what we did, what are all that will help the teaching community students to do better in research domain. So we taken that as a theme for the conference, that is advances in computing intelligence and informatics. So based on this theme, focused around it, we have concluded to have 5 tracks, because this advances in computing intelligence and informatics mostly focused on data and technology. Most of the data that comes from the IoT devices. And when we are dealing with the data from the IoT devices, we need to have computer networks, extended strategy planning for the security. This led us to have a track on artificial intelligence, machine learning, a track on IoT and applications, a track on computer networks and cyber security. So further, to devise recommended systems, to have inference engines, to have intelligent engines, we need to have data-driven approaches, then high-performance computing. That is how these two also added as a track. So we had 5 tracks for this particular conference, which was discussed much at the beginning of inception level of the conference and well appreciated. And we also maintained a quality metric for making this conference a quality conference. We followed the easy chair score above 1.5. We have seen the plagiarism has to be less than 15%, and all the papers are reviewed by 3 authors through easy chair. This is a quality measure that we followed. So as a result of this, we could have only 44 papers among that 42 people are presenting during these 2 days. So to conclude, I wish you all an enlightening conference. It gives remarkable memories to go back to your places, which will help you to make the students better, to make the research better, which is helping to improving the country or nation at a big way. So I wish you all a wonderful, enlightening experience and enjoy the hospitality of Anurag University. So I thank all the organizers and I thank all the dignitaries on the dais. Thank you all.
We are honored to welcome Mrs. S. Neelima, CEO, Anurag University, to please come on to the dais.
Mrs. S. Neelima completed her BTech from JNTU Hyderabad and MTech from Osmania University. She served as an engineer in Transco for over 2.5 decades. She is a managing trustee of Gayatri Educational and Cultural Trust, which manages the Anurag Group, and has been actively involved in the organization's operations for the past 10 years. We welcome you, ma'am. Now I request Dr. V. Vijay Kumar, Dean School of Engineering, Anurag University, to address the gathering.
Good morning to all of you. Respected dignitaries on the dais, the Honorable Chancellor, the Honorable Vice Chancellor, and the Chairman of Anurag University and the CEO of Anurag University, and Ms. Samin Fatima, the former Registrar of the Anurag University, and today's guest of honor, Dr. Vishnu S. Pendyala and Pratyush Notalapadi, and the chief guest of this conference, Professor B. Egnanarayan Garu, and the deans and heads of the departments, and my dear colleagues, and my dear students, and my dear participants, and the press and media, a very warm welcome to all of you on behalf of the organizing committee of this conference. The entire department of CSE, under the leadership of Dr. G. Vishnumurthy and Dr. M. Sridevi and Dr. M. Balakrishna, launched the second conference, ICACII 2023, with an aim to provide a platform for researchers, scientists, academicians, industrialists, engineers to exchange their innovative ideas and new research findings in the field of computational intelligence, covering almost all fields of computer science and engineering and electronics, and also interdisciplinary fields. From the report of conveners, it is understood that the aim of this conference is fulfilled. And also from the report of the Dr. G. Vishnumurthy, out of 42 papers that have been selected, 42 presenters also came today and tomorrow to present their ideas and their papers, means the conference aim is completely fulfilled. I strongly believe the conference will boost the practice of innovations, and also I wish that the department should take the conferences again and again. I suggest the participant to establish a connection between them to carry out the proceedings of this conference to the next level. Because usually what happens is, whenever we come for a conference, whenever we present a paper, we usually exchange our ideas. But today, I request all of you to carry out this link further so that it will help you in your future innovations. I thank the Department of CSE for their continuous efforts and the higher authorities of Anurag University, especially the Honorable Chancellor, Vice Chancellor and the Registrar, and also other deans for encouraging to conduct this type of conferences and workshops and valuable insights. Finally, I would like to thank the management for giving constant support and also constant encouragement, and also whenever there are funds are needed, boosting the funds to encourage such type of activities in the entire campus. Thank you.
Thank you, sir, for enlightening us about the conference. Now I request Professor Samin Fatima, former Registrar, Anurag University, to address the gathering.
Distinguished Chief Guest, Professor B. Yagnanarayana Garu, Honorable Chancellor, Professor U.B. Desai, and Vice Chancellor, Professor S. Ramachandram, the guest of honor, Mr. Pratyush Nutalapati from Deloitte, Dr. Vishnu Pandiala, guest of honor, CEO Mrs. Nilima, Professor Muttaredi, all the deans and heads of the departments, and my dear invitees, my dear students, a very good morning to all of you. I told first. Yeah. I think Vishnumurthy is prompting me. He didn't hear me wishing our Professor Yagnarayana. He's the first person in my list. And he's my role model too. I'm very happy that the organizers have called me back to Anurag University for this beautiful event, the conference on advances in computational intelligence and informatics. I think it's my privilege to be here and to learn a lot from this conference. There are a lot of people who have worked very hard, especially Dr. Sridevi and her team, and Dr. Vishnu, Dr. Vijay. I congratulate you all for putting up such a good conference together. The year 2023 has been the year of LLMs, large language models. Recently, you must have seen something circulating in your WhatsApp groups. Sundar Pichai of Google has announced that with an eye scan, you can tell the age of a person, you can tell the gender of the person, you can tell whether the person smokes or does not smoke. You can also find out the cardiovascular diseases just by an eye scan. The prediction of what is the cardiovascular disease, just with an eye scan is amazing. It's an amazing feat of AI. You don't need any CT scans, you don't need any MRIs, you don't need any X-rays. You know how hard it is to go through all this. Anybody who's got a cardio problem, or in your family. Today, AI is able to predict all this just by taking your eye scan. Isn't that wonderful? Now, my dear friends, when I was here, when people were taking admission into BTech AI program, I told them, why are you taking admission into BTech AI? And they used to tell me that because AI does not have math in it. So they were not well informed. So I thought this is a platform, because I see a lot of young faces, students, maybe young faculty too, who are available here. Some of you may be aware, some of you may not be aware, but AI owes its strength to mathematics. Its prowess comes from mathematics. Mathematics, the marriage of mathematics and AI is very essential in making all these predictions. you have a very simple thing which you call as an equation. But this equation is a very powerful thing. From a simple linear regression equation to complex neural networks or deep learning equations, they're all equations. Y is equal to mx plus c. Who does not know that? X is the input, y is the output, m is the slope, and c is the intercept, right? And you have the input and you get the output, you can make the predictions. Isn't that beautiful? This is how AI and math get married to each other. You use beautiful mathematics to make predictions of the output in AI. Now, another very important concept, that we borrow is that of probability. We are living in a very uncertain world. You know, the world has become very complex today. You see things happening in so many different ways. There's so many paths, so many different things that you really can't pin down and be very certain about what you're doing, right? Even if you make a prediction, sometimes you're not 100% correct. So probability is another very important concept that needs to be understood to make predictions. Be it predictions of the stock market, be it predictions of your medical ailments or diseases, be it predictions of the weather, be it anything. Again, you have a notion of probability. How certain are you? Are you 100% sure? Supposing if I say that Google is giving you only 95% correct results, it's not 100%, don't use Google. Will you stop using Google? You will still use Google. It's fine to be 95% correct. But if I say that I'm going to operate on you, and I'm 95% sure whether the operation is going to be successful or not, even then you'll say, okay, let me think it over. So sometimes you have to be very sure, and sometimes maybe you can tolerate some amount of uncertainty. So every time in research, we try to improve the performance of our systems. And that's very, very important. The third thing, my dear students and my dear young faculty, is that we need to optimize. There's something called as optimization. And optimization of the parameters has to be done in AI. And optimization of parameters in AI, again, as a very simple example, is your gradient descent, which everybody learns in mathematics. So starting from there, you use your mathematical optimization techniques to get optimal solutions. You optimize your parameters. By doing so, your predictions become more and more accurate. You know, ChatGPT, how many parameters it uses. Okay? And then finally, the parameters that it's using is not helping it. So they have come up with their reinforced learning with human intervention. And now the recent one, they're not disclosing as yet. What is the heuristic, what is the algorithm, what is the technique that they're using. So each day they are improvising, but without the support of mathematics, AI cannot stand on its own. I think with this message, I would like to thank the organizers for giving me this opportunity. God bless you and thank you again.
Thank you, ma'am, for sharing your valuable insights with us. Now I invite Professor S. Ramachandran, Vice Chancellor, Anurag University, to address the gathering.
Today's chief guest, Professor Narayana, and the other guests, Dr. Vishnu Pendyala, Mr. Pratyush Nutalapati, our Chancellor, Professor Desai, and other dignitaries on the dais, and all those who have come to participate in this conference. Good morning to all of you. Yeah, first of all, I should congratulate Professor Vishnumurthy and his team for doing a wonderful job. In fact, I remember 1.5 years back, he came to me actually, and then he said, we will do the conference in December. Then I told him, how can you do in so short time actually? Then he said, no, it is in 2023, December. So he came to me actually, um, not for the permission as such, but he came to me for the support, financial support. Hopefully, I think he got the support from the management. Yeah, they're a wonderful team. In fact, they have been working very hard for the last year. And then, of course, I came to know there are invisible people also, right? So I should thank all of them for doing a great job. Yeah, just now, Professor Samin Fatima has told you, what is the impact that this technology is making. Computational intelligence, sometimes we call it as artificial intelligence, maybe sometimes machine intelligence or machine learning. There may be subtle differences, but then they're all, making a huge impact on all of us, right? In fact, I would say that they are enhancing our capabilities. Or, in other words, if you want to be good, you want to be efficient and probably effective, then you should be using all these technologies. So it's very imperative, I would say. Yeah, that's a change, that is transformation that is happening. In fact, my own experience, I'll tell you, the other day, we wrote a program, but I'm not able to pinpoint where the mistake is. I, decided to give it to ChatGPT. All right, it gave me, exactly pinpointed where the error is and what is the solution also. So that is the kind of thing, that's happening. Probably we should think the way we develop the software. It is impacting the SDLC, software development lifecycle, affecting actually the way we write the code, we debug it, we test it. All that is changing. That is in software development. But otherwise, it is having an impact on every walk of life. So as just now Professor Samin Fatima told you. In fact, it is also changing the way we teach. Yesterday I had gone to Usman University. So all our teachers actually were discussing whether we should use such questions, ask such questions in the examination for which ChatGPT is giving good answers. Yeah, that's a big question mark actually. We don't know actually, right? Also, it's changing the way we teach also. What should we teach? How should we teach? And how you do research, conduct your research. Okay, these are, I'm just, because these are, pertaining to me, so that's why I just cited these examples. But then I also feel that these things also should be discussed in such, conferences. Okay. I'll not spend too much your time. Once again, I congratulate our team, and I wish you all the best. Thank you very much.
Members on the dais, distinguished members in the audience, conference participants, welcome all to this particular conference on my behalf. This conference is very apt if you look at the title now. I mean, there's a variation here, computational intelligence and informatics. We like to play with words. Essentially, everything is nowadays revolving around AI. I mean, Dr. Fatima talked about it, Dr. Ramchandra talked about it. I think this is making a huge impact. in all sense of it, and there are various issues which are being talked about, not simply what AI is doing, it's doing a lot, what it will do. There are many who are scared. All kinds of regulations are coming into picture, and we need to be careful and not throttle the innovations that take place in AI. Okay, so there is a lot of buzz, lot of activity. There's a lot of hype also. A lot of exaggeration is there in terms of what AI can do, what AI is doing. Okay, so various things are there, and I think this conference is very appropriate in that particular context. Generative AI, as they call it nowadays, whatever LLMs, ChatGPT, etc. That's the flavor of the season, and wherever you go, everybody is talking about generative AI. But the key driver, and I think this perhaps needs a lot more attention than AI. There are a lot of AI models available in open source. Anybody can download and use those models. Of course, you need good computing facilities. Data. Without data, there is no AI. Okay, and jokingly, I used to say that for once, the research in AI is going to be very different. Traditionally, research was done in academic institutions. Leaders were institutions like Stanford, MIT, and others. Okay. Today, 5 corporations are going to dominate AI. Why? They have the computing power, but more than that, they have the data. Take anybody in this audience. You are subscribing to one of these corporate. Many of you have Gmail, right? So everything, whatever you do, Google knows more about you than what your parents know or you yourself know about it. Or you go with Microsoft, okay, Azure Cloud, etc., etc. Or you go with AWS. So you pick one. Many of you may be Apple lovers, so then you are stuck with Apple. Now they have all the data in the world. It's not simply data in US or in Palo Alto or in Bay Area. They have data in a tiny little town like Jumri Talaya also. Okay, so the issue is now, how is this AI going to evolve? And if you look at India, we talk a lot. I've been involved writing policy papers, documents, white papers since 2018. And I tell this at every meeting that I attend. 6 years have gone by, no genuine action has been taken by the government, because the government will get very angry at me. 6 years in AI is worse than losing the World Cup in Ahmedabad. I think there's nothing much left. In a sense, the world has moved far ahead. And I'll give an example as to where they are moving ahead. ChatGPT will look like passe. Argonne National Laboratory in the US is developing something called the science brain. And what are they looking at? They are looking at a trillion node network, not a billion node network, 1,000 times more complex than a billion node network. They are looking at trillions of pages to create as I said, a science brain. They are looking at an exaflop machine. In India, IICs and IITs have a petaflop machine. They are looking at a machine which is 1,000 times faster than that. So the race is a very uneven race and a very complicated race. At least India, which is, in my opinion, very rich in data. But our data is all fragmented. Just look at the language data we have. You travel 50 kilometers, 100 kilometers, the dialect changes. But we have no data properly put together. Last I heard, I think Mr. Nandan Dilkani has given a large chunk of money to IIT Madras to create a huge data corpus related to language technologies and with different kinds, which is very great. We need a lot more of that. I think the focus needs to be a lot more in terms of usable data and not simply raw data. So I leave it with this particular thought as far as the conference is concerned. And I'd like to congratulate the organizer of this conference. What I was very happy to see in the data is the acceptance percentage for the conference is only 20%. Also, another happy thing is they have got a lot of international participants and international keynote speakers for the conference, which will be really a great thing for the participants. You will be able to learn about what is happening broadly in AI, data science, and related areas from people across the globe out here. So, a special congratulations for that. And I'm sure all of you will benefit, and I sincerely wish the deliberations will be really exciting, vibrant, and some fruitful conclusions will come out of this conference. Thank you very much.
respected dignitaries on the dais and off the dais. The very fact that we are all dignitaries, the very fact that you're attending a conference makes you a dignitary. Conferences are great places where knowledge is unleashed, right? You take techniques that you study in your textbooks, like LSTM, generative adversarial networks. These were unleashed in the conference called NeurIPS. Similarly, association rule mining was announced in a conference called VLDB, variational autoencoders. It was announced in ICLR. So conferences are great places where knowledge expands, right? That's where the knowledge unleashes. The Sanskrit word for creator is Brahma. So Brahma means, Bra means expanding, Ma is for mind, expanding mind. Creation is all about expanding mind. In that sense, the conferences are symbolic of the expanding mind, expanding knowledge, right? Mind is nothing but knowledge, right? So, artificial intelligence is an exciting field. The other reason that you're all dignitaries is because you're working in artificial intelligence. That's what I presume, right? There's a conference on computational intelligence. So artificial intelligence is an exciting field. My undergrad project was in artificial intelligence. My supervisor was none other than Professor Samin Fatima. Professor Ramchandram and Samin ma'am were my professors when I had a lot of hair on my head. But unfortunately, there was a long AI winter when I lost all my hair. So during those 20 years or so, which was AI winter, I did something else. Then AI came back, and I came back to AI as well. See, AI is what made me sit on the dais along with my professors. See, that's the power of AI, right? So it's a great, exciting field. So make the most of the conference. Try to grow your knowledge, try to grow your network, try to grow your interest also. So these are most important. Many people underestimate, many conference attendees underestimate the power of conferences in networking and making connections with people. Don't sit in your chair all the time. Just move around, talk. Of course, when there is a talk, please do attend, because the next, following this inaugural session is my keynote, and I expect all of you to be there for my keynote as well. So the other point I wanted to mention was Samin ma'am introduced LLMs, right? LLMs, it's a very simple idea, right? I don't know how many of you have closely been observing LLMs. The idea itself is very simple. A linearity followed by non-linearity. Y is equal to mx plus c that madam mentioned, followed by a sigmoid function. That's all. That is all to the ChatGPT and the LLMs. In fact, there is something called a nano GPT. I don't know how many of you have know about that. It's a small implementation of the GPT by Andrej Karpathy. I don't know how many of you know Andrej Karpathy. Elon Musk calls him the greatest computer vision scientist in the world. So he implemented a nano GPT, which is just 300 lines of Python code. That's it. So 300 lines of Python code. Simple concept, but it can do wonders. See, it's all about the scale, right? A lot of linearities followed by non-linearities is able to do such marvelous things. So I'm sure you will discover a lot of such things in this conference as well. I wish the conference a great success, and I congratulate the organizers for putting up this great conference. And I'll save my technical part for the keynote, which is just following this inaugural. See you then. Thank you.
Thank you, sir, for sharing your insights and suggestions with all of us. Now I invite today's guest of honor, Mr. Pratyush Nutalapati, Managing Director, Dept Consulting, to address the gathering.
Good morning, everyone. I did not prepare a speech yet, but I just pulled in impromptu, so I'm going to talk a little bit. This is one of my favorite topics that I've been exploring since last 3 years. So let me start with the iPhone movement in the AI, right? November 2022, when the GPT 3.5 came. That's the first time when AI moved from the nerds and more educated population to more of the mass population, right? Now anyone can go in and ask a question in GPT, and it can give you an answer that you might have to search like 20, 30 links within Google. So what did it do? It amplified and accelerated everything that we are doing right now in our lives. So I call this more like an age of width. What it means is that humans and machines are going to work together in the new world. We're going to co-create. We are going to work together. And what it translates into is that we need to have a proper governance and ethics around the AI. So as the next generation of programmers coming in, I would suggest that you also embed a little bit of ethical nature into everything that AI can do and work through it. So from a Gen AI perspective, we have been doing some metrics and benchmarking. What I realized is that the acceleration is phenomenal, right? When we did the first assessment of what the Google, AWS, and even the GitHub and other things have been bringing up into the market, between March of 2023 and September of 2023, things have changed quite a bit. So now if you're like an ex-programmer who has left the programming, coming back, you can now create the same program at 80% efficiency. What we have seen is that the new developer who comes into the program, who is just learning the ways of working, are getting an efficiency of up to 30%. So, and also the way you create code, you experience it, is also changing quite a bit over time. And we are seeing that with just one prompt, it's going to change the world. So I would actually request all of you to think of more like prompt engineers, because AI is all about prompts and how the outcomes are explored from the prompts that we are going to create. Right, that's number one. Number two, the models have become more omnipresent. What it means is everyone can access it for free now. Back in the days, you need to know more about AI and how it operates. You need to learn a lot. Now you don't have to. So people are now using, almost I know every person now in my industry is using ChatGPT in one way or the other, in as simple as how do you write an email, to as complex as how do I do a security program. So it is being helping us across the spectrum of it. Right? If you look at code construction, some people have talked, now we are using prompts on, for example, if I want to build a website, right? In the past, you did not have so much of content available for you to learn and evolve into that space quickly. But with the new options that you currently have, you can be a very experienced programmer in just 6 months with the kind of prompts that you can create. You can now create an entire mobile app with a single prompt using something like a Buzzy.ai. And there are so many tools coming up, and also what we have seen is the acceleration of tools availability is going to create a lot of cognitive load on people, because there are about 1,500 apps that are being generated every week in this world right now. So every problem that someone said P2BL, right? So every problem that the new generation is seeing, they're trying to see how do you solve it using AI. And so please be ready to be working together with AI and trying to co-create with them together. Thank you.
Thank you, sir, for sharing your knowledge with us. Now I invite today's chief guest, Dr. B. Narayana, Emeritus Professor and INSA Honorary Scientist, IIIT Hyderabad, to address the gathering.
Good morning. I would not have come if I knew that Professor Desai will be here, because I'm just nervous sitting alongside with him. He is my colleague for 40 years, and we were collaborating technically for a long time. And it's a great honor and privilege for me to come here and share the stage with Professor Desai and other dignitaries. About the subject, topic of this conference, initially I thought I may be misfit for this But then when I saw the title, I'm a member of IEEE Computational Intelligence Society for the past 25 years, 30 years. In fact, since its inception, before it was called Neural Network Society. But of course, although I'm not contributing anything these days, but I used to write some papers almost 20, 30 years ago and so on. But when I saw the contents of this, I'm a little surprised that, there is very little of computational intelligence that was thought about at that time. In fact, if you see the journals and articles in computer science, recently only they introduced IEEE transactions and AI in that, although since I knew, and I still have many journals of 90s and 80s, if somebody wants I can hand it over to them because I don't know how to use them. So I want the fundamental, basically I think I should also tell about myself. I am a counter to all the people sitting in the dais and off the dais here. I am a person who looks for problems in solution rather than solution for problems. Because I'm basically a researcher and want to remain as a, that's why I don't get a job in industry anyway. So, but what is surprising to me in the last 10, 50, although of course I am senior and in fact most senior among all of you, maybe, and also I am not in, you may be thinking that I am not in touch with many things, but I am in touch, although I may not know in details. And the terminology that we use in recent times, recent means last 10, 15 years, is so baffling. And if you carefully, of course, one good thing about most of us, especially students, is they don't think anymore. But if they think, you get confused. In fact, even somebody gave me a label of professor of computer science, I don't know, by mistake, 40, 45 years ago, and I live with that. And all kinds of terminology. In fact, when I entered into computer science in late 70s, I was thinking, where is science in computer science? See? And then slowly, of course, lots of things have happened and so on. Now data science, I keep wondering, where is science in data science? It's very interesting. Please note that, you see. Because if, and also one, maybe I'm different from everybody here. Because although I have not done anything in AI, but AI started when I was in college, 1956, you see. And then, of course, we started in 60s. We had a course, semester course, 3-credit course on information theory already. And so on. Of course, I followed what was going on, although I never contributed anything. But, symbolic logic in 60s and heuristic search in 70s and expert systems in 80s and maybe neural networks and then slowly machine learning and now deep learning and DNN and I don't know what's going to happen. And surprise, okay, you may not question, but I keep questioning. I worked in neural network for 40 years or 50 years and so on. I don't know what is very neural network in DNN. And I work in human learning and how to convey learning, what is learning and so on. I don't know what is deep learning. Deep learning has nothing to do with learning. Why I am highlighting this point is there is so much more for us to learn. God has created human beings, human brain in such a way that it should not be understood. The day you understand, you don't feel like living anymore. Please note that. And the AI itself has changed its meaning over a period of time. And earlier, at least, there was expert systems AI. Then neural network was not considered as AI really. It was Ellen Rich, and in her book, she introduced a few chapters in ANN later, so on and so forth. But later, in 2000, that is last 2000 to 2010 and so on, this AI is almost forgotten. They call AI winter, AI summer, all this forget about it. You see, the whole problem here is, somebody asked me to teach AI course. I said, no way. Because I taught AI in 1980s for 3 years for IIT students. and I have about 50 board. And if you ask me to teach AI, nobody will come to attend my class. Because that's what we talk about AI today is not really the AI that was talked about in the beginning or throughout its evolution, but what we do, we call it as AI. What we do with the tools, we call it as AI. That is the problem. And somebody mentioned about the impact of AI on us. No. Impact of technology on us. No. We should be impacting the technology. Technology should not impact us. You see, I think somewhere we lost our direction and so on along the way and so on. Not that AI is unimportant. You see, ChatGPT, I'm not an expert in ChatGPT. Please note that. You should take my statements with my ignorance also along with it. So the point, ChatGPT, natural language processing, large language models, there is nothing natural in this natural language processing. In fact, since it is this inaugural session, I don't want to waste your time, but just ponder over it. All naturalness is removed, and the volumes of text data that you have created with Microsoft Word correcting all your sentences, making it so unnatural as it can, and then start deriving the models out of it. You call it natural language processing? What I am talking to you with all my gestures is natural language. Is natural language. And what you are processing is natural language. Why I am setting, not condemning anything. Please note that. We should see that goal and we should keep driving it. And along with the tools that we evolve over a period of time and so on. None of the tools that we develop now will exist after 5-10 years. You see? Something else will come and we have to adapt ourselves. The challenge for human being is our adaptation, not just learning a skill. We just, unfortunately, Python into all our campuses. So it is, gobbling all of us into it. You see, Python should be taught, but not in our campuses, but outside the campus. Fortran programming language should be taught out. We should be thinking, using those tools. That is the point we have to, because we are permanent. We are learners. We should be thinkers. You see, please understand, this AI term will change again. It will change. In fact, you will see DNN, you talk about, there is not a single concept of neural networks in DNN. Pardon me for saying this, you see, because I wrote a book on UNN. And I have about 100 ANN books on neural network books in my shelf and so on. If any of you happen to see Handbook of Brain Theory, well, it's wonderful to see what is neural network supposed to be. You see. I think we should understand, and then of course we have to move with the technology. There's no question about it. But we should set apart, in my opinion, about 20% of our time thinking, what is happening here? You see, already Sam Altman is saying, new model is coming, don't worry about it. In fact, I may be wrong in my terminology because I'm not a technology. I think it is called Super GPT or Q star, something like that. Q star is the one that's going to come and so on. If that comes, what do we do with all my skill in the GPT and so on? I think these are the, but we should learn. We should learn quickly and also change quickly if possible. That is the, you see, this AI, please don't understand, it is difficult to understand probably, each person says what AI, his own version of it and so on and so forth. But we should not make ourselves, our intelligence artificial. Even industry wants intelligent people to work on artificial intelligence, not artificial intelligence people. Thank you very much for your attention.
Thank you, sir, for your time and sharing your expertise with us. Now I request all the dignitaries to join for the souvenir release. It's a great honor to invite Dr. Palla Rajeshwar Reddy, Honorable Chairman, Anurag University, Member of Legislative Assembly, Janagaon Constituency, Telangana, onto the dais.
Dr. Palla Rajeshwar Reddy, the founder of the Anurag Group, is a visionary in building the educational ecosystem of Telangana for more than 2 decades. He completed his MSc and PhD from Osmania University and started his academic career as a faculty. Dr. Reddy had started Anurag Group in the year 1998 with few UG and PG courses, later adding engineering, pharmacy, and management courses, providing quality education to over 20,000 students. Dr. Reddy, with his dynamic leadership and vision, has been successful in catering to the needs of students. He entered politics in the year 2014 to serve a greater section of people with his passion and commitment. He is presently elected MLA for Janagaon Constituency, Telangana. Hearty congratulations from all of us. It's a great honor to welcome sir to address us in this gathering.
What are the people present here? One second. What are the people present here? Narayan garu, Mother, మన కన్వీనర్ దీంట్లో. So good morning, all of you. Respected Vice Chancellor Professor Ramchandran garu, Registrar ma'am, the other sitting, the people sitting from the Computer Science Department, the Dean of the University, Professor Vijay Kumar garu, Dean Computer Science Vishnumurthy garu, Sridevi garu, and chief guest on the occasion, Professor Narayan garu, eminent professor of INSA, honorary scientist, IIITH, Hyderabad, and guest of honor, Dr. Vishnu Pendyala garu, academic senator, San Jose State University, USA. They call it as a Sanos, I think. Pratyush Nutalapati garu, the MD Deloitte Consulting, and Nilima garu, CEO of the university, Professor Muthareddy garu, Dean Exams, and others sitting on the dais, and my dear delegates, faculty and friends who came here to attend this second international conference on advances in computational intelligence and informatics. Once again, good morning, all of you. I'm sorry for making it at the last minute. I'm always interested to participate from the beginning, to learn the people from outside whenever the guests, the chief guests are coming. I always learn, cherish their words, speeches. Today I missed it. I was a little away from the academics for the last few years. Even though I hold the chairman of this Anurag University, most of the time I am spending elsewhere. I am also listening and attending some of the meetings in the university, but we have the strong academic leadership at Anurag University. The chairman sir, the vice chancellor sir, and Samin ma'am, and also the eminent chancellor Desai garu. Just now he has gone out to attend an important call. And also all the deans and directors of and almost HODs are there for the almost last 2 decades. This institution began its journey in 2001 as an engineering college. This has become university 4 years back. But people who have joined here as a faculty, they are pursuing their teaching and also research. And actually they are here, we are able to retain them for the last 2 decades. And they are doing actually, I did my research in physics in the Usman University in collaboration with the DMRL, Defense Metallurgical Research Labs, way back in 1990s. I worked as a faculty for some time. I did not get chance as a researcher to continue, but I have been encouraging my faculty to do research even after completion of their research PhD. And this kind of conferences definitely helps to continue our research in our own field and also to learn the latest advanced subjects in the computer science. It is fast changing, and after 1 year or 2 years, whatever we learned is becoming actually not useful. Maybe that may be in the stores, but every day the computer science with so many new subjects, new programs. Actually, we should be under the computer science faculty, and also the researchers and students should be on toes. Otherwise, they are redundant. So we have to learn the latest topics. So towards that only, I am encouraging my deans and also the HODs, the faculty also, to attend conferences wherever it is possible, whether it is the national or international. And the second, we have to conduct the national or international conferences to hear, to learn what are the advances taking place in the subject. And also we can have definitely the very good friendship with the people who are working in the field, so that we can at least learn while speaking to them, while be in contact with them. So definitely, I don't want to discuss on the subject of this matter because I am really layman to this topic. I think Professor Eginarayana garu and the guests from Deloitte and also Sanos, they are the competent to speak, and also I think they may be participating in the further other sessions. I appeal all the participants in this conference, please concentrate this duration of this, whatever the proceedings taking place. So don't think that actually I know this thing and also like that. Please concentrate to learn whatever you know also. So when they are presenting, when they are interacting with you, when they are presenting on the particular paper, sometimes it bounces. But please be patient to learn the things. Definitely, the proceedings of this conference will help you to increase your knowledge in the particular subject. That helps you to learn actually that intricate, that definitely tells you that, okay, I have to learn some more things in these things. Sometimes if it is in your own field, you may feel that, okay, I know this one. Otherwise, if it is a new field, that helps you to go further, to learn and also pursue your quench for the learning. And this is the continuous process. When we are learning the things as a teacher, earlier teachers are different, present day teachers are different. Earlier teachers, there was no source of information. The information was only the library for the students, the then students. Two decades back, the students, when we were students, the teacher is the great. Whatever he taught is the actually we used to learn. And if we get one book from the library, that is the greatest thing. When I was doing research, even for the literature survey, I had to go to the Delhi, I had to go to the Indore, I had to go to the Central University, Hyderabad, I had to go to the Andhra University for even searching journals. The journals are also not available. It was very costly, and I used to go to the pillar to post for getting the literature. Right now it is not. It is available on your fingertips. Whatever you want on your palm, I think everything you are getting. So that is why the teachers also, earlier teachers were they are the one of the main source. The second one is the books. That's all. But right now, teachers not only they are also one of the source. That's all. But remaining thing, everything you are getting through. Even the website, if you go, you will be getting everything. And the teacher job also has become very complicated and very complex. Earlier when we are teaching, we feel that in the 40 or 50 or 60 class, we feel that they doesn't know anything. Whatever we say, that is the mantra, that's all. That was what was the teacher taught was an important those days. But today, what they learn is the important. What is the outcome on your class? What is the outcome on your chapter? What is the outcome on the particular subject is now measured, and that is the important. So what teacher taught was earlier important. What student learned is today's important thing. So that is why the teacher always, there are the 60 people, means earlier 60 people were the questionless, even answerless, questionless, anything. But today, all the 60 are the questions only. Everybody is having some knowledge. If we raise something, if something is wrong we are teaching, definitely he raises and says that, sir, you are wrong, sir. So this is the source, and I learned from this thing. So that number of sources, latest topics also coming to them. So the teacher's role has become more complex, more competitive, more challenging. So in this time, I request all the faculty members to learn the latest topics, and also please conduct, even after this conference also, please try to maintain good relations, friendship with the participants of this thing, so that as a collaborative learning you can learn more, you can do better. When you have you will be respected more when you have the best paper. When we were in the university, I am concluding with this, when we were in the university, if somebody publishes paper and he put it in the notice board, and we always feel that the friends feel that proud of him, and the others feel that professional jealousy used to be there. Okay, he has published so and so paper in the great publications. So that was the quality, that was the measure. So in which journal he or she has published. So when they used to publish in the some physics journal of physics, and it was the international journal, very few people from the India used to get chance to publish in that. So with that, actually everybody says that this guy is published his paper in that one. So that goes for the 5 years or 10 years. Everywhere, oh, his paper is published in so and so. So that is the value, credibility of the paper publishing. So I request all of you, please pursue your research. As long as you want to be in the academics, you have to pursue research. Otherwise, your earlier days, one of the teachers used to say, for last 30 years I taught only this subject. Nobody cares. If you teach today one subject, tomorrow another subject, next year another subject, then you will be a great teacher. And how you are teaching with the latest, if you are taking the references from the journals and those things, then only you are a great teacher. So I think the teachers who are pursuing their research and also teaching in the field, they understand well. So without learning the latest topics, without going to the research, the teaching itself is you will not be respected. You will be stagnated. So that is why I request all of you to continue your research in the advanced topics, and I hope and wish the proceedings of this conference will definitely help not only our faculty, not only these people who are presenting this one, this also helps the entire computer science fraternity everywhere. And with this, I thank even the Aginarayana Garu and other guests for giving time and spending to our learners. Whatever the knowledge you have, you are sharing. So thank you very much, sir, for coming here and giving your time. And also, I thank all the participants for making this success. The success only, the proceedings are published, and it is when it is referred by others, then only the success of the conference will be there. So with these few words, thank you very much for giving me opportunity. Thank you.
Thank you, sir, for your valuable time and your valuable inputs. We assure you that definitely we'll be taking it into consideration and we'll be using them for our growth in our career. Thank you, sir. Now I request the dignitaries on the dais to felicitate today's chief guest, Dr. B. Egna Narayana. Now I request the dignitaries to felicitate today's guest of honor, Dr. Vishnu S. Pendyala. Now I request the dignitaries to felicitate today's guest of honor, Mr. Pratyush Nutalapati. Now I request Dr. P.V.S. Sivaprasad, Professor, Department of CSE, to present vote of thanks.
Good afternoon, all of you. Respected dignitaries on the dais, of the dais. I, Dr. Shiva Prasad, take privilege in presenting my vote of thanks. So definitely, human intelligence has to be thanked. So I take this opportunity. I thank our chairman, sir, who is inspirational to us, Dr. Palla Rajeshwar Reddy Garu. I thank CEO, Ms. Neelima Madam, who is always behind us, helping us. I thank Chancellor, sir, Dr. U.B. Desai, for his constant support. I thank Vice Chancellor, sir, Professor S. Ramchandram Garu, for taking his time, addressing us, helping us all the time. I thank Registrar Dr. Balaji Utla for his support. I thank Director of Strategy and Digital Learning, Anurag Palla sir. And I thank Chief Guest, Professor B. Agnanarayan, for taking his valuable time, coming here, addressing us, inspiring us. I also thank Guest of Honors, Dr. Vishnu S. Pendyala, Mr. Pratyush Nutlapati. My special thanks to Professor Samin Fatima, former registrar. Wonderful, her speech is very enlightening. I thank Dean School of Engineering, Dr. Vijay Kumar Garu, who is always helping us, guiding us in the department. I thank Dean CSE, Dr. Vishnumurthy Garu, who is dynamic and backbone to this conference, constantly giving right guidance to us. I thank Dr. M. Sridevi, convener, who is behind this conference, working hard. I thank co-convener, Dr. G. Balakrishna Garu, who is just like a flowing fluid in this conference, connecting everybody, all resources of this conference. I thank deans of various schools of Anurag University for their support. My special thanks to publishing partner Springer for this conference. And the most important, I thank external and internal reviewers who have taken pain in reviewing all the papers and selecting them for this conference. I also thank resource persons for pre-conference workshops. We have conducted 5 pre-conference workshops. Big image data processing using deep learning. I thank USN Raju, Associate Professor, NIT Warangal, who has come along the way and given his guest lecture. Then Essentials of Cyber Security by Mr. Srinivas, former Chief Information Security Officer. Then another track, IoT platforms and software applications, Bharadwaj, Smart Bridge Senior Developer. AIML, Mr. Saumya Mohan Dasu, Mr. Praveen Babu, ML Engineer, Smart Bridge Private Limited. Another track, High Performance Computing, Mr. Bala from Microsoft, Mr. Pavan from Honeywell Technologies. I should thank all those sponsors who have supported this particular conference. You can just visit their stalls. And definitely, track in charges have to be thanked. They have taken a lot of pain in keeping the tracks, students and resource persons. I thank all other departments, HODs of Anurag University. And my special thanks to organizing committee members. Without them, it is, I think, difficult for organizing this conference. I thank CSE department professors, associate professors and assistant professors for their support. And I thank all the researchers who have contributed their knowledge and who are going to present in this conference. I also thank students who have taken active participation in enhancing their skills and knowledge. I thank press and media for their support. And I thank all other who are connected directly or indirectly for making this conference possible. Last but not least, participants from outside Anurag University and outside Telangana. I thank one and all. Thank you for giving me this opportunity by the organizers. Thank you, sir.
Now I request everyone to join us for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभाशिष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद।
Let us have a break for 10 minutes and we'll reassemble here for the next program.
Video play, ma'am.
Confused చేస్తున్నావు.
Welcome all the computer science fraternity to participate in the second international welcome all the computer science fraternity to participate in the second international conference on advances in computational intelligence and informatics organized by Computer Science and Engineering Department of Anurag University.
I am sure that this conference proceedings and discussions and deliberations is going to enhance the knowledge in the computer science field, especially in the dynamic areas like artificial intelligence, image processing, pattern recognition, neural networks and security, and also in other areas.
With 5 special tracks focused on all emerging areas, 9 keynote sessions, 2 plenary talks, five pre-conference workshops and many other events.
I invite you and welcome you to participate in this conference. Welcome all the computer science fraternity to participate in the second international conference on advances in computational intelligence and welcome all the computer science fraternity to participate in the second international conference are advances in computational intelligence and informatics organized by Computer Science and Engineering Department of Anurag University.
I am sure that this conference proceedings and discussions and deliberations is going to enhance the knowledge in the computer science field, especially in the dynamic areas like artificial intelligence, image processing, pattern recognition, neural networks, and security, and also in other areas.
With 5 special tracks focused on all emerging areas, 9 keynote sessions, 2 plenary talks, 5 pre-conference workshops, and many other events.
I invite you and welcome you to participate in this conference. welcome all the computer science fraternity to participate in the second international conference on advances in computational intelligence and informatics organized by Computer Science and Engineering Department of Anurag University.
I am sure that this conference proceedings and discussions and deliberations is going to enhance the knowledge in the computer science field, especially in the dynamic areas like artificial intelligence, image processing, pattern recognition, neural networks, and security, and also in other areas.
With 5 special tracks focused on all emerging areas, 9 keynote sessions, 2 plenary talks, 5 pre-conference workshops, and many other events.
I invite you and welcome you to participate in this conference.
Good morning to one and all. We welcome you again. It's our honor to welcome today's speaker, Dr. Vishnu S. Pendyala, Academic Senator, San Jose State University, USA. Sir is a faculty member in the Department of Applied Data Science and an academic senator with San Jose State University, chair of IEEE Computer Society, Santa Clara Valley chapter. He has over 2 decades of experience in the software industry, Silicon Valley, and delivered several invited talks as an ACM distinguished speaker. He holds MBA in finance and PhD, MS, and BE in computer science and engineering. He taught a 1-week course sponsored by MHRD, Government of India. He recently served on a US government's National Science Foundation Proposal Review Panel. He is the recipient of many awards, Distinguished Toastmaster, Area Governor of the Year, and Silver Scribe Awards. We welcome you, sir, to deliver your lecture for our audience.
Thank you, madam, and welcome you all to the keynote talk. So we all are here to know more about artificial intelligence. As was mentioned in the inaugural session by Samin madam, artificial intelligence is playing a great role. She gave the example of the eye retina, right? From the eye retina, the machine learning software is able to recognize a lot of things, right? Including heart disease and things like that. So artificial intelligence is actually surprising even the doctors. See, doctors are able to only look at what the eye can capture, right? But machine learning algorithms are able to capture things that the human eye cannot see, that the doctors cannot see. So ma'am gave the example of retina of the eye, but actually ECG, electrocardiogram, right? So there are papers, research papers, which have found out that the ECG can tell you the age, the gender, whether the person is having diabetes, hyperthyroidism, kidney disease. So all this can be predicted just based on the ECG, electrocardiogram. Humans cannot do that. Humans, when a cardiologist sees the ECG, he will not be able to predict diabetes and hyperthyroidism or kidney disease or age, right? But machine learning algorithms are able to do that. Similarly, lung X-ray. From lung X-ray, you can tell, the machine learning programs can tell whether the person has diabetes and things like that. So it's an exciting field to be in artificial intelligence. And I don't want to repeat the power of artificial intelligence with respect to the large language models, ChatGPT, self-driving cars. You all know the power, right? Like 50 miles from where I live, San Jose, there's a place called San Francisco. Taxis come when you haul a cab, but the difference is that these cabs do not have a driver. They are self-driving cars, right? So it is still under test phase, but soon it will become production ready, thanks to machine learning and artificial intelligence. So then what is the problem? I mean, why do we even talk about the social predicament? Predicament is a difficulty. So what is the social difficulty that artificial intelligence have? So let us hear from a prime minister of the country, a technology godfather, a serial entrepreneur, and a religious leader. What is the predicament that artificial intelligence poses? So I'll...
तबाह करने में भी सबसे बड़ी भूमिका निभा भी सकता है। डीप फेक का चैलेंज आज पूरी दुनिया के सामने है। आतंकियों के हाथ में एआई टूल्स के आने का भी बहुत बड़ा खतरा है।
So that was from a prime minister of a country, from this country particularly. He is cautioning us that artificial intelligence, if it gets into the hands of terrorists, then we are all finished, right? And then the godfather of artificial intelligence, Geoffrey Hinton, he resigned his post to make some public comments. So he says that AI might escape control by rewriting its own code to modify itself. So it's like a Terminator. That's what he is indicating. I don't think we are there yet, but many years ago, or a few years ago, I think 6 years ago, right? 2018, it's about 5 years ago, 5.5 years. Elon Musk said that, mark my words, artificial intelligence is far more dangerous than nukes. And then the religious leader, Pope, he was once a victim of artificial intelligence, and calls for a treaty to regulate artificial intelligence. So artificial intelligence is now everybody's business. We have seen people from different walks of life warning us about artificial intelligence. That is a social predicament. So this news is from the 15th of December, that is last week, right? So artificial intelligence is everyone's business. We have to be concerned as well. So we let the big people worry about doomsday. I don't think it is there yet, but if at all it is there, we'll let them worry about it. But for the lesser mortal like you and me, what predicament does artificial intelligence pose socially? This is actually a very hot research area. You will see why. So there are a lot of ideas that are being explored. So I'll give you some of these topics, present some of these topics, and present the issues they pose, and then the solutions or research directions going forward. Right? So the first one is privacy. So privacy is a big thing. I'll start with a cartoon. I like to make my audience laugh at least once a while. So, so this is a cartoon. We all do typing on our phones and laptops, and then we get auto-prompted, right? You type a few words and the system starts to auto-prompt. So so in this cartoon, this guy typed some strange words, like he typed, "Long live the revolution, our next meeting will be at." And then the system prompted the docs at midnight on June 28th. So that's actually a confidential meeting going on somewhere in the world. And these guys apparently are trying to do something drastic. And the system, which is run by artificial intelligence, prompted the exact location. So this is just a cartoon. But in reality, this happens to be true. I mean, cartoon, you might be thinking that we are never there. But it is actually true in certain contexts. So these researchers, Nicholas Carlini and others, they presented this paper in 2021, where they found out that giving prompts like this, in this case the prefix East Stroudsburg, when they typed that phrase, it actually listed all the details about a corporation. Fax number, phone number. So that's what they say. This is a quotation from the paper. Given query access to a neural network language model, we extract an individual person's name, email address, phone number, fax number, and physical address. See, it's a serious concern, right? See, our address, we don't want to expose our address, right? For various reasons. We don't want people flocking at our door for unwanted reasons. But interestingly, the system GPT, which is the precursor to ChatGPT, today's ChatGPT, was overfitted. I mean, why did this happen? because there's something called overfitting in machine learning. So it has overfitted to the data. It has actually memorized the data. Instead of being general enough, it was impacted by overfitting, and it actually memorized the data on which it was trained. And it was revealing very sensitive details. So this is a serious concern for all of us, right? So more such incidents. I don't want to take a whole lot of time. We are already running short of time. There's a video that a webinar that I presented to University of Bolton. So if you're interested, you can watch it. But the interesting part for today's talk I wanted to show was this website called haveibeentrained.com. So you can actually type your photograph, for instance, or some domain, any information about you, and see if the models, large language models, there are tons of large language models, right, these days. You go to huggingface.com. Huggingface.com is increasingly becoming the GitHub for models. You can download a model and start working on it from Hugging Face. So there are tons of models, so large language models. So this program will tell you whether the data you input has been used for training these large language models, right? So just to test it out, I gave my own book called Veracity of Big Data, whether LLMs have been trained on this book. And interestingly, first point to note here is that there are 500, at least 500 illegal copies of my book on the internet. So much for the copyright. So that's one thing. And the other thing is, yes, obviously the book has been used for training the large language models. And I can tell this website that I don't want this data to be used for training the large language models. So you can say, do not train, and the system will automatically convey to the large language models to exclude this information from the model in the future. So that's about privacy. Like I said, there are many examples like this. You can watch that video that I pointed to, University of Bolton. You can search my name, University of Bolton, you get that video. So you can watch those examples there. The other big problem is diversity, right? So I think some of you are students here. You would have done some programming exercises with the Boston housing market. It's a standard data set available on the UCI website. So they actually retracted it, right? I don't know how many of you have know that. They actually retracted it because they found out that there was a lot of bias in the data set. So you can search Boston housing market data set, it won't be available anymore. It was one of the popular data sets for students. I used to give exercises to my students based on this data set. But some student pointed out that, see, I'm not able to get the data set. How should I go about doing the homework? So data sets are being redacted. That means removed from the internet because of bias and diversity problems. A great example is this from yesterday, I believe. This is yesterday's news. Rite Aid is a medical pharmacy company, medical pharmacy store rather. So it's a chain, and so they have, 2 days back I think, Wednesday's news. So they used facial recognition for a number of years, and that system misidentified Black, Latino, and Asian people as likely shoplifters. So I am an Asian, I walk into Rite Aid store to buy some medicine, and then the system will send an email to the owner or the employees by email or phone telling that this shoplifter has entered, please be careful. So the system recognizes me as a shoplifter just because I am an Asian. And what is more disturbing is that the store employees would accuse the people walking into the store in front of friends, family, and other customers of previously committing crimes. They would say, you committed, you stole stuff from the shop, so we don't want to service you. So it is so insulting. So the federal government, FTC, Federal Trade Commission in the United States, prosecutes these kind of problems. So they prosecuted Rite Aid, and then they entered into a settlement. And according to the settlement, Rite Aid is forbidden from deploying facial recognition technology for 5 years. From tomorrow onwards or today onwards, for 5 years they cannot use facial recognition technology. So that is how serious the problem is. So there's a lot of stereotyping in the artificial intelligence models today. You can test. So there's a website called, of course, this is also a Hugging Face website. Under Hugging Face, there is something called Diffusion Bias Explorer. So these days, diffusion models have grown in importance in computer vision, right? So DALI 2 and stuff like, for instance, the very first slide, the image is from DALI 2. I generated the image using DALI 2, artificial intelligence, right? This image. This image is from DALI 2. I just gave it some prompt and it generated it for me. So DALI 2, there are a number of models. You can actually query, using this website, you can query various computer vision models to see if there is any stereotyping. For instance, I chose what DALI 2 thinks about an honest lawyer, right? So when I typed, I want pictures of an honest lawyer, it only gave me faces of white people, no women, all white men, and mostly bespectacled. They have spectacles, and so that's the stereotype, which is not true, right? I mean, women lawyers are also honest. There could be women lawyers who are honest. There could be Asian lawyers who are honest, right? So, but DALI 2 was trained on only the white men who are honest lawyers, and therefore it only generates white people, white men as honest lawyers. So you can try this website out. You can try various stereotypes and see how biased the artificial intelligence models are. So diversity is a very big thing today. So there are more such examples. Again, this presentation was from last year. I gave it to the same University of Bolton in United Kingdom. I'll not play it, but you can always type, you can search for these videos on the YouTube channel. There's also another presentation that I made organized by our own college, our own university. So you can also search on that for more examples of these kind of issues and some solutions.
Today we are.
So recently we also published a paper at the beginning of the year. This paper won the Best Paper Award. And what we did was we tested a lot of methods to correct the bias problems in artificial intelligence models. And then we found out that the experiments that we did demonstrate that some of the oversampling techniques, the correction techniques, can actually degrade the models, both in terms of performance and fairness. So the model, there's a lot of scope for research in this area. So the existing techniques that we have currently, they are not all that. They in fact increase the bias, decrease the performance, and increase the problem of fairness and diversity. Then there's also a recent research work called Fair Diffusion. This paper is not yet published. It's a preprint by Friedrich, Felix, and others. So this is an interesting concept. So in DALI 2, what you do is you give a prompt, English statements, and then it generates a picture for you, right? That's how I generated the first slide. So these researchers, what they did is, in addition to the prompt in natural language, like in this case a photo of a firefighter, they also give fair instructions in addition to the prompt. So this is like a lookup table. So they would give a table of information to tell what is fair and what is not fair. And just like the diffusion models take the prompt in natural language to generate the image, the diffusion models now take the prompt in English as well as the fair instructions from the lookup table to generate images which have more diversity and which are more fair, right? So in this case, if this fair instruction lookup table was not input, then probably we would have had all men as firefighters. But in US particularly, firefighters could be women as well, right? So with the fair instructions, it is able to generate women images as well. So this is an interesting research which is yet to be published, but it is available as a preprint. So closely related to the social aspects of artificial intelligence is the environment. So these days, ESG investing is very popular, right? ESG stands for environment, social, and governance, right? So ESG is getting popular. Particularly, people are trying to invest in companies which focus on the ESG aspects, environment, social, and governance. So environment is a big thing connected to the social aspects. So if you look at the carbon footprint of the large language models like ChatGPT versus the common tasks, the training itself produced 171,000 kilograms of carbon dioxide, right? Training BARD. And ChatGPT, the carbon footprint is like 340,000 kilos of carbon footprint was left because of the training. Just to compare, if you send an email, it takes, the carbon footprint used is from 0.01 to 0.1. And if you watch a YouTube video, it is from 0.1 to 0.5. But if you query ChatGPT, if you type a prompt and ask ChatGPT something, it will take anywhere from 2.5 kilos to 12 kilograms of carbon dioxide footprint. So that is how expensive ChatGPT queries are. So it's a big problem because see, we are suffering, right? When I was in Hyderabad many years back, weather was so pleasant. It was not this bad. I mean, today flooding, a lot of things are happening. US is even worse, right? There's a lot of flooding happening, a lot of devastation is happening. So climate and environment play a very important role. See, the Sanskrit word, I keep going back to Sanskrit because that's it has a lot of insights. The Sanskrit word for air is pure, right? Pavana is purity. Water and air are considered to be pure. They are purifiers, basically. We are impurifying the substances which are supposed to make us pure. So that is what is causing all this devastation. We are going against the nature. So carbon footprint is a very important thing that we need to be very cautious about, right? What gets measured will improve. So there's a Python package. You can go to this website called codecarbon.io. You can do a pip install of the Python package and use it in your program. And it will tell you how much carbon footprint your program will use. Right? So we are trying to make the developers cautious or conscious about the carbon dioxide emissions from the computing, right? So that's the other thing. So now how do we handle the predicament? How do we handle the difficulty? So to a common man, we look to the government, right? For all our problems, we blame Prime Minister Modi, right? We obviously do that. That's the easiest solution. So But there is some fact, there is some truth to it. So governing AI is very important. And last week or last 2 weeks back, European Union agreed on AI Act. They did not pass it as a law, but at least there is some agreement among the European Union nations. The act itself is very interesting. So some of the things are completely prohibited, right? Like social credit scoring is prohibited, and behavioral manipulation. This is a big thing, actually. I'll not go there, but behavioral manipulation is a big thing. Presidential elections have been manipulated in some other countries using this behavioral manipulation. So it is prohibited now. And so a lot of stuff like that, and law enforcement use of biometric identification in public has been banned as well. So that is what is banned. And then there is a second category of high-risk AI, which is slightly less problematic. So medical devices, for instance, is high-risk AI. Self-driven cars, right? They are high-risk AI. Recruitment. So you all know about this news, right? Amazon was using a machine learning program to shortlist candidates for hiring. And it was found that those systems were biased against the women candidates, right? So if a woman applied, the application would most likely be trashed. It will not be selected. So people found this out, and then Amazon had to redact. It had to eliminate that program of using AI for. So that is high-risk AI, because employment is an important thing. So European Union has rightfully identified it as a high-risk AI. So, so these high-risk AI systems have to be registered. European Union requires them to be registered. And then there should be an assessment done. So every high-risk AI will be assessed to see if it violates any fundamental rights. So all the countries' constitutions have some fundamental rights, right? Like in India, there are 7 or 8 fundamental rights, right? Or 10, I don't remember exactly. I studied it many years back in social studies. So United States also has some fundamental rights in the Constitution. They're not exactly in the Constitution, but they are amendments, the Bill of Rights amendment. Every high-risk AI has to be assessed with respect to the violation of fundamental rights. So that's a very big thing that the European Union AI Act requires. And then registration, we already talked. And then data governance is also important, like eliminating bias and mitigation. So they should show proof that they made sure that the bias and is mitigated in the AI model. Then transparency. So these are all active research areas. So what does it mean to you? I mean, most of you seem to be students in this auditorium. So what does this mean to you? That means the government is going to pump a lot of money into these areas. Even companies. When government mandates something, companies have to invest a lot of money on these ideas. So that means there are a lot of jobs in these areas, right? Each of these areas, there's a lot of budget, and therefore there's a lot of jobs. So transparency is another big thing, right? So explainability, interpretability. So those are really important. And then human oversight. So today morning, Samin ma'am talked about the ChatGPT use of reinforcement learning with human feedback, right? Human in the loop. So that is increasingly a trend in artificial intelligence. So human oversight is important. We want, like Professor Yaginarayan also said, right? We want humans to be in control, not the technology. Humans should impact the technology, not technology impacting the humans. So that is one of the essential aspects of EU Act, AI Act. Similarly, White House, so White House did not even wait for all this parliamentary process. They just passed an executive order. The president passed an executive order. which has a lot of implications as well. They are quite similar with respect to AI Act, but so it requires, this executive order requires safety test results, just like the European Union requires assessment. United States requires safety test results, then some proof that these systems are safe, secure, and trustworthy. And then the executive order also wants, there's an organization called NIST, National Institute of Standards and Technology. So they want NIST to come up with best practices for detecting AI content, generated content, and so on. And then a lot of things like this. I think I'm running out of time, so I'll probably rush through some of these things. But you can always look up online. This is actually easy to understand also. It's not too complicated. So the executive order itself is quite easy to understand. So a specific section is there for algorithmic discrimination, like the hiring discrimination and things like that. There's a special section for that, fairness and tutoring and so on. But I want to strongly caution that we should not rely on the government to do everything for us. It's very important. Responsible AI is everyone's responsibility. We are all responsible for making AI responsible. So do not leave it to the government to solve all of AI's predicaments. This is very important. I'll give you an example. So this social media, you would have read news that social media is causing a lot of suicides, mental health issues. In fact, United Kingdom, I believe, recently banned or is trying to ban social media use for under 16 or something like that. They're trying to regulate the use of social media for kids under 16 years old. So it is that serious. See, in US, I don't know about in India, but in United States, if you want to do a small survey and publish those results, we need to take the approval of IRB. See, in my class, I used augmented reality and virtual reality for teaching machine learning. So I did a survey just to know the impact of AR and VR in teaching machine learning. So I wanted to publish a paper with that. I contacted the IRB just to be on safe side. Then they said, you should have contacted us before, not after doing the survey. So I should first approach IRB, then they will give permission to do the survey and things like that. So social media is such a huge experiment on the people of the world, right? Where was IRB at that time? Where is government at that time? Right? It is causing so many deaths. For a small survey, augmented reality use in my class, I had to take permission. The law requires me to take permission of institutional research boards and things like that. But for social media, where was all this law? Right? So that's the reason why we cannot entirely rely on the governance, on the government to do everything for us. We need to take proactive action. So that will be the topic for my next talk sometime in the future. But now I want to, in fact, I'll be giving this presentation on responsible AI in a couple of weeks from now, but in a different place. So then the next thing I wanted to talk about is using AI as an opportunity. Right? AI presents a huge opportunity as well. So we can actually use artificial intelligence for governance. See, recently Telangana had elections. I don't know how many of you are happy or sad about it. I'm pretty sure that not everyone is happy about the elections, right? That's the reason why the results are so split. So how much can we entirely trust people with decision making for all of us, right? So that is the reason why I've been pitching in my own way for using artificial intelligence in a big way for the governance of the people. So more than people, I mean, people are important. Technology should be in the control of people, but it should be aided by the technology. So I wrote this op-ed, which was published last month, on democracy being driven by artificial intelligence, right? So what I want to propose, so there's another op-ed that I wrote, which got published just a few hours back. Of course, it was edited, because what I proposed originally was to change the US Constitution, to amend the US Constitution, to incorporate data science and artificial intelligence, right? So the very first article and very first section of that article of the United States Constitution states, all legislative powers herein granted shall be vested in a Congress of the United States, which shall consist of a Senate and House of Representatives. Just like we have Lok Sabha, Rajya Sabha, they have Senate and the House, right? So now I want to propose that it is high time that we append that statement with supported by a body of data science tools and technologies. So instead of just having a bicameral legislature, bicameral is 2 houses, Rajya Sabha, Lok Sabha. I want a third house, make it tricameral. The third house will not be of people, but it will be of tools, big data tools and technologies, to ratify what it's a check basically. The government runs by checks and balances, right? You have the executive, judiciary, and the legislature. They all run by checks and balances. I want a new check to be added, and that check is the data check, right? So obviously, this will not go well with the people of United States, right? A small Indian coming all the way and telling them to change the constitution, right? They don't like it, so they obviously changed it. By the way, the United States Constitution was hardly amended in the 400 plus years of its history. There were just a handful, I don't remember the number on top of my head, but there were just a handful of amendments. So amendment of United Constitution is really a big thing. Constitution is something that every citizen upholds very highly in the United States. So amending Constitution is not, but they did publish my thoughts, but with a different title. They titled it as, it was published just a few hours back. It is still December 21st in the United States. So artificial intelligence can take the politics out of policy making. That is the title of the talk. So with those thoughts, I will end my talk. I thank the organizers for giving me this opportunity. And please feel free to get in touch with me. I am on social media. I have a website. So feel free to connect with me, and we can continue the discussion there. But in the meantime, if you have any questions, I'll be glad to help you. I think I have some time for questions, right? Yeah. So any questions? So no questions means it was so mesmerizing that you are still thinking, or you have not understood anything. I don't know which of that is true. Or the third reason could be that you are hungry and I am coming in between your food and you. Okay, there's one question here. Is there a mic? Or you can speak up. I probably did not get the question. So, Adobe? Yeah. Okay, so I get your question. So you are basically questioning the very reason we are using AI. Yeah, that's a good question. That's a very important question. which was partly answered by Professor Samin Fatima in the morning, right? So, like she said, AI is an approximate theory. You use software when the problem is deterministic, when the solution needs to be deterministic. So if you want to be very sure of the answer, then software will help. But there are many situations where things are not completely given to you. See, for instance, ChatGPT. You cannot frame the exact prompt, right? So when your prompt is approximate, the answer should also be approximate. So that is the reason, that is the area where AI plays a role. So when the domain is approximate, that's the best candidate for artificial intelligence. So your Adobe tools and all those things, they use AI because it's not deterministic. If you examine the usage of AI in Adobe tools, it's not deterministic. There is some amount of probability, some amount of guessing in what the tool is going to do. So that's why they are using AI. So you should not look at it like that, right? See, ATM machines or teller machines, right, for the banks. So just because they were introduced, did we lose clerks in the banks? No, right? So it's just a tool which is of use for improving the quality of life. Similarly, when calculator was invented, math teachers did not go out of job, right? You still have math teachers teaching kindergarten, first grade, second grade. Just because calculator is there, those jobs did not go away. So same thing with artificial intelligence. There is still room, but the quality will improve. Does that answer? Thanks for the question. Yes, sir.
Thank you very much, sir. Thanks for the wonderful session. After looking at the carbon footprint slide, so I have to think twice before asking any question in ChatGPT, because I never expected that amount of carbon footprint released in every query. That was great information for us. Yeah. For each and every question, 2.5 to 12 kg of carbon footprint. Yeah, that's huge. And my question is, you explained the importance and impact of bias while training the models. As a researcher and on behalf of all the researchers, I want to know how we can handle this bias when you are working on the model. Is there any standard procedure for that, for handling the bias, so that model can be trained properly?
Yeah, thanks for that question. So bias basically stems because of the data, right? So the data is, if it is very specific to certain categories. For instance, in California, for deciding bail applications, of course, judge makes the decision, but the decision is driven by, that's what I mentioned in my op-ed also. The decision is driven by artificial intelligence. So the artificial intelligence model will tell whether to grant a bail or not. But the unfortunate part is, if you look at the data set on which the model is trained, most of the criminals, I mean, that's the reality, right? Most of the criminals belong to certain race or things like that. So the data is biased, and the bias is modeled after the real world. There's bias. The real world is unbiased, unfortunately, right? So the data set is also biased because of that. So what is the way to balance the data set? So we need to balance the data set so that it is representative of all the communities, all the diverse groups. So the only way is either undersample the data or oversample the data. So those are the two main ways of fixing the data. Of course, there are other tools like we saw diffusion model. We can give you, we can input some prompt for fairness and do. So it's a actively researched area, but yeah, currently the most common way of addressing bias is by by balancing the data set. Thank you. So in the paper that I mentioned, that's what we did. We tried to balance the data set using a number of techniques, and we found out that the techniques are not all that to the mark. Thank you. Any other questions? Yes.
Predict or classify the data.
Right.
Compared to your ML and DL, we have newly generative AI. So where it keeps on generating the data on millions of parameters. So we know some evaluation metrics are there to evaluate your machine learning algorithms and your deep learning algorithms. So how we know the LLMs are generated accurate data? Is there any specific metrics that we can know for this generative AI?
Yeah, there are metrics. That again is a growing research area. There are a number of metrics. A simple metric to start with is a BLUE score, which is probably used in deep learning models also. So it's BLUE score. The BLUE score basically measures the similarity between the generated output and the expected output. So that is a very simple technique, which is not all that to the standard. So researchers are still coming up with the metrics. So it's another area of research. Thanks for the question. Okay, I think we are done with the questions.
Good afternoon, sir.
Good afternoon.
So, your session is so wonderful. Just I want to conclude one doubt which I'm having right now. So as we are working here, we are producing our students as AI engineers, ML engineers like that. So as today we are seeing in our department 70 faculties are there in CSE only. We are happy. But if you go for previous days, 4 years back, only 37, 35 were there. But we are producing our students to make AI projects, models. No doubt after 10 years or 5 years, they are going to produce the AI robots. They were replacing us. Then what is the solution for that one?
So I did not fully understand the question.
See, what my question is, we are developing students.
Yeah.
We are developing students. No doubt students, after 5 years or 10 years, they are going to develop the robots which will replace us.
Right. Okay.
Then what about the stomach?
Oh, so you mean the job scenario. So jobs. So yeah, so that's a valid concern. But the thing is, if we use the technology properly, it should actually improve our quality of life. See, one of the op-eds that I published very recently, I said that to get a 4-day work week, we need to invest more in artificial intelligence. So long back, it was a 6-day week. Right? When I was a small kid, companies were working 6 days a week and 9 hours a day or something like that, right? 9 or 10 hours a day. But today, it is 8 hours a day and 5-day work week. Why did that happen? Because of technology. So we should, if we are careful enough in handling technology, then it should improve our quality of life, not impact our quality of life. So we should still have a job, we should still get paid well, but the amount of work that we do should reduce. That should be the ideal approach. So just like I was telling another member in the audience, right? ATM machines did not replace bank clerks. Similarly, calculator did not replace a math teacher. So similarly, AI models and robots will not probably replace people, but they will make their lives better. See, software engineers' jobs are under threat right now, right? Because of GitHub Copilot and all that stuff. So it can be seen as a threat. On the other side, it can be seen as a way to reduce the load on the software engineers. Software engineers are heavily burdened, right? So if you use Copilot and things like that, the AI tools, it should actually reduce the load on the software engineers and probably give 1 day back. So instead of 5-day week, it should be a 4-day week if it is used correctly. But you're right, there is some valid concern if the CEOs and the executives are too greedy, they want more and more money, then yeah, you're right, things can go haywire. So it has to be cautiously governed. Yes. Technology has to be cautiously governed. That is the solution.
Thank you, sir.
Thank you.
Just one more doubt. As AI is going to replace, no doubt, in health sector also. So doctors, they are doing the operations based on that AI robot like that. But all the inputs it is given to that software developer. So it is based on doctor only. Doctor is going to set what is the sugar level. Like before fasting, it is like 110. After fasting, it is 170. Based on different doctors, different countries. Maybe in India different, maybe in America different. Based on that, they are going to have that operations. Whether that is okay.
So that is a general problem, right? I don't think it is related to artificial intelligence. If the medical standards are different, then yeah, the results will be different as well.
Thank you. Thank you, sir.
All right. Okay. So I think we are out of time. Okay, thank you all.
Thank you, sir, for your knowledgeable inputs and thought-provoking session on artificial intelligence. Now I request Dr. Tinagaran Perumal, Associate Professor, Department of Computer Science, University Putra, Malaysia, to deliver his keynote session on consumer-centric Internet of Things, innovation and future of computing. Dr. Tinagaran has completed his PhD from University Putra, Malaysia, in the area of smart technology and robotics. He is currently an associate professor at Department of Computer
can collect data, and they have some sort of connectivity, right? Of course, the notion is not new. It's been there since 1998. But we don't see much impactful growth in Internet of Things due to several reasons. One very particular reason is because of the consumer acceptance. Who is consumer? We are the consumers. We as the user, we are not sure whether we can accept IoT devices as we accept our mobile phone, right? Today, everybody is having your mobile phone as your personalized devices. But would you accept your IoT devices as your personalized device? Just like when you use Instagram or Facebook, right? You have some degree of trust on it, right? You're very comfortable to use that. So that's the billion-dollar questions, actually, what's happening now. So before we go further, I think it's very important for us to understand what actually meant by Internet of Things object. So basically, you can categorize into 3 different categories, right? The first would be passive object. I believe everybody use credit cards, bank cards with chip, right? So this kind of card we call as passive card, which has some contextualized information, nothing more than that, right? So it can store information and then you can update, that's it. Then the second category is actually the reactive objects. Okay, this is something that you see when you put up remote control to turn off your aircon, right? When you use your remote control to turn on your set-top box, right? Your DVD players and so on. So there is some reactions, right? You press something and something happens, right? But the third one is the most biggest challenges, and that's what will be the directions of Internet of Things, which we want to see every object to be autonomous. So what is autonomous? Autonomous means that it doesn't take the instruction from me, it has to do the task by itself, right? So autonomous is where the final vision or direction of Internet of Things, where we expect that domains like EV, electric vehicles, right? Something like Tesla cars, and any objects that can do something on autonomous, right? But remember, this is not that easy because there are a lot of, I would say, bottlenecks that we have to surpass. So basically, if you want to convert an object, let it be your BTech projects or MTech projects if you want to do an IoT related systems. The first thing that you have to understand fundamentally what the object is and how we can develop an object. So to transform an IoT object is not that difficult. Basically, you need your physical object and then you integrate with particular sensors, right? So these sensors is based on a domain. Let's say if you're working on smart homes, like when you talk about smart homes, it's all about controlling devices, right? So you might want to have a temperature, you want to have a humidity, or probably you want to connect or control your CCTV cameras, your security cameras, right? So these are things that you can embark on object. So the example here shows you how you can have your smartwatch. Okay, smartwatch is actually a wearable, which is common in the market, right? So whenever people talk about Fitbit, fitness trackers, you get this. But how does this smartwatch can be materialized? Take up a watch, put up couple of sensors, then give them an IP connections, that's it, right? And of course, you have other value addeds like storage and so on. But here, this is how we perceive objects all about. So right now, we have smartwatch as an IoT objects, wearables, but we don't have much other things. And whenever you go to market or whenever you go to the malls, whenever you want to buy Apple Watch or any other smartwatch, normally the applications are limited to healthcare. Very much healthcare or fitness tracking, nothing more than that, right? So this is the laid back in the wearable development. And I will tell you why. So many countries today, right, they are going by sectors. So they want to see how IoT can be bring closer to the users, right? So instead of putting an abstract, I think it's very important to give a real use case to the consumers, right? And often you see tech companies, they talk about manufacturing, they talk about healthcare, public service, but on the bottom line, you don't have much, I would say, impactful use cases for the consumers, right? So this is the current happenings, right? So when you go deeper, when you see the definitions, those abstractions are still very high because many tech companies are looking at how IoT can be defined on abstract level, meaning on telecommunication side, on very infrastructure level. So sometimes when you want to realize common applications, you don't need this hype or infrastructure level definitions, right? So I would say that like there are many consortiums like IEEE, ITU, M2M, ETSI. Basically, they are very focused on infrastructure, and they don't give much benefit to the consumer side. But again, I would say that it's very interesting to see the definition coined by IEEE, where they say that an IoT system is a network of networks, or where typically a massive number of objects, things, could be a sensors or devices that connected through communication and information infrastructure to provide value-added services. Here, the keyword here is value-added services via intelligent data processing. So what we understand, if you want to embark on IoT project, there should be some sort of intelligence. Otherwise, it won't be functional, right? So this intelligence can be any form. It could be AI, it could be generic machine learning, or it could be any rule-based schema, right? Rule-based is very classical thing, right? So, and of course, you can use this IoT for different applications like any domain, like smart cities and so on, right? So this could be the first step to understand. So today, after many years, right, when see the tech companies, I think even in the talks previously, even in the morning speeches, I think most of you have heard about the term generative AI, ChatGPT, on how AI can be, usable for this kind of domains. Yes, we do accept that, but in IoT, the case are very special because you can't put entire AI into it, only on the certain phases. For instance, right, when you talk of generic IoT, you have data collections, you have how to store the data in the cloud, and then you process the data, then you analyze, you do some analytics, and then you finally do some control. You will act upon it, right? But when you put AI into that, normally AI would be beneficial if you can automate the way you collect the data. So for example, if I say that, generally IoT sensors, we talk about volumes. For example, if I have a bridge infrastructure, I need to install probably 1,000 to 1,500 number of sensor nodes, right? So this is where AI can help me. Instead of manual configurations, I can use AI to do automated configurations, right? Or selective configurations. Or probably I can ask AI to do some sleep mode to save the energy. I couldn't do that, right? And then storing it, of course, the cloud platform today are very stable. You're talking about Azure, you talk about Amazon Web Services, okay, which is very stable in the cloud domain. And then processing it, analyzing it, and then act upon it. So here, a lot of new things, breakthroughs are coming on how do IoT device uses AI to act upon it. Meaning that you want to react, you want to use to control that, right? That's going to be the main objective. So in very simple term, what's happening today is that the moment you apply artificial intelligence of things, the only thing you can do is to disconnect because you're already connected. When you talk about autonomous, seamless, means the device already registered on the network and it is already has an AI capabilities. Right? So the concept is like you have an objects. The first thing is to finalize firm on the object types, right? Like pointed like passive, reactive, and autonomous. And then from then you need to know about the local network. So local network, normally we have issues. Why? Because no manufacturers or maybe probably organizations wouldn't allow you to share your IoT device on the same network that you use for enterprise computing. For example, if you are in a campus, you have a Wi-Fi, right? If I allow an IoT device, it's going to be a third-party device, there might be a breach of security. So this actually pretty much related to the IT policies, right? And this could be also one reason why we don't see much exposure on IoT devices in the ecosystems. So like if you want to use IoT in organizations, definitely there should be separate protocols, separate network connectivity. Apart from Ethernet or Wi-Fi, there might be other considerations like Bluetooth or LoRa and so on. Okay? And then of course the cloud services, data either sent right to or received from the cloud. So we have a very stable workflow today in the cloud. And then how we connect to the global network, and finally we ensure that ability to connect to our consumer devices, which is very close to us, right? So talking about consumer-centric, okay, for us, we like to expect, normally users want something that can converge, both technology, telecommunications, and data together. At the same time, it has some influence on the industry, and as a user, we like to see the IoT as a need, not a complications, right? If I want to wear a smartwatch, at the same time I want to pair it with my mobile phone, there should be seamless. There shouldn't be like power issues, like maybe I need to charge my smartwatch quite often, right? We want to avoid that, right? So and pretty much we like to see some humanization aspect of technology. The technology should help, not to be burdened, right? So why is it a next big thing? Because first it's all about the application. So if you look at the applications, mostly Internet of Things applications are motivated by actual problems. Okay, so if I talk about waste management, how do you segregate those wastage and then distribute to the waste management sites? So these are some practical real problem, right? So if you look around us, look around you, there could be a lot of real world problem which could be a great test bed. It's the only thing that we don't embark on the use cases because we are carried away with the use cases we got it from textbooks. Generally, we talk about smart home, smart city, which might not be relevant for us because every use case for IoT should be culturally connected. The contextual should be culturally connected to the local, right? So if you ask in Southeast Asia, smart home might not be a good use case, but smart city, yes. Because we are dealing with larger populations, right? So smart home might be good in countries like US or Japan or Korea, right? Where they have less dense populations, bigger cities, bigger states. But in Southeast Asia, like India, right? So probably we are more dealing with the large populations. So that should be the way we should look forward, right? So there should be also some facilitations how we do cross-cutting applications, like it's no more that we work in isolations. Today, even a machine learning engineer has to work with an IoT engineer, right, to see the right matching for the use cases, right? So the interaction between stakeholders is very important. So this is a very, very nice infographics. Okay, it's about Libilium. Libilium is actually the IoT device and kit providers, right? So they come up with a very out-of-the-box use cases. And if you see that, they don't just talk about smart home, smart city, but they also talk about forest fire detection, right? They also talk about water quality. They talk about sportsman care, which is something unique. If we can say that it's out of the box. So I would say that M-Tech projects or even B-Tech projects should go in that directions. You create a new niche use cases based on the local context, right? So the second reason is because the scale. The scale, why? Because we see sometimes IoT can be applied in a very large scale, can be very small scale, right? So many areas like when you deal with outdoor environment, okay, particularly buildings, right? And very often people talk about energy saving, right? But it's never ending problem, right? And then about the safety, security, and healthcare, of course, right? So not just on the application overviews, we should also look at the research part that could address a very specific problem. So the third reason would be, of course, it cut across the entire computing stack. Okay? So what is the computing stack? If you look at the bottom line, it's all about hardwares, right? You come up with the microcontrollers, you try to see whether you can use BeagleBone, Arduino, Raspberry Pi, and so on. Then you go for other platforms, other sensors, and then slowly go into the operating systems, right? And then this is more on the programming part, on the bottom line. And then, of course, a much higher layer would be the connectivity. The connectivity layer is ever expanding because there are not limitless choice on what protocols you should choose, right? Of course, generally we thought about Wi-Fi, but Wi-Fi might not be a good protocol today. Might be a different protocol, might be applicable. Then you have ensemble programming, like you apply some rules, data storage, and finally on the top is where we see the analytics part. Here we expect the front-end application developers looking into the machine learning, deep learning, or even generative AI to come up with a complete ecosystems of consumer-centric Internet of Things, right? So if you see that, if you talk about generative IoT, for example, how generative AI can help users in terms of consumer-centric IoT. Okay, for example, if you see that today, when you talk about multi-platform sensors from different architecture, different platforms, you will have issues on code integrations. How do I use cross-platform codes, right? So using generative AI, large language models can be used to create complete or combined IoT codes and source from code snippets or natural language description. So this actually cutting down the development life cycle. You don't spend much time on the bottom layers. You cut down the development life cycle. So this could be one example how generative AI can help code development, right? And of course, in areas like robot control, generative AI can be used to generate controls and commands of IoT connected robots by capturing motion data. So this is more on applied. You can use generative AI to capture motion data, okay, from animals or humans. And then the third one is very interesting, is about social IoT device. It can actually use to change the interaction within devices. Devices, could, for example, could provide the users with answers to complex questions. So I give you an example, a scenario. If you're talking about smart home applications, smart home based IoT. Let's say you're installing a smart home platform in your house, and you have many family members with different profiles, different user interactions, preferences, right? You have different comfort level, maybe you have different preferences of temperature, you have different preferences for musics, and so on. So the home has to recognize the profile and has to automate based on the respective profile. And this is where generative AI can be used to prompt to see the right user profile to launch the smart home platform. Okay? So this is just a bit of it. Okay, there are more coming up, right? So today we have a lot of enablers, and we don't have issues to develop IoT applications because you have cheap sensors, cheap bandwidth, okay, better processing. Okay, of course, everybody has their own smart homes, ubiquitous wireless coverage. Big data is very mature today, or even we call it massive big data today. And then IPv6, the way the IP is connected. So not much issues for anybody to start a project on it, right? So of course, we are dealing with the heterogeneous interconnected objects. Heterogeneous means that you are dealing with the diversified of infrastructure. It could be sensors from different platform, different manufacturer. So that's the only issues. And then of course, we need to make sure that when you develop an IoT project, it has to be rapid and almost closer to the real time, right? So with today's GPUs, all right, processing power, this could be solved amicably, right? So one has to remember that the real philosophy of IoT is not in the connectivity, but in the services. So it's like one day we want to, if you left your objects, if you left your mobile phone somewhere, I think you just need to open your Google browser and then type out your phone's name, and it will show you exactly the locations. But this is the final vision. It won't happen that fast, but this is what the directives of IoT philosophers. So for example, if you look at this diagram, what you see is actually a racket. It's actually a badminton racket or tennis racket, you can call it, right? So the main function of racket is for playing games, right? Nothing more than that, right? But if I want to transform this racket into an IoT-enabled racket, I must have a clear use case. I must have a clear reason why I want to do that, right? So if let's say if I put some batteries, I put some accelerometers, if I put some gyroscope, if I put some SD cards, right, for storage, and I put some network interface, probably Bluetooth or Wi-Fi. So now what's happening, I can collect some data, and then I can store the data, and I can push to the cloud. But is it relevant for me to collect such data? Yeah, that's the question we need to know. Because you can actually transform any objects into an IoT objects, but how is it relevant? How much it relevance to the real use case? So are we going to measure something here? Are we going to measure the player's performance? Or are you going to measure the player's strategic movement? So if yes, you can go ahead. Otherwise, it's a waste of effort, right? So there must be a clear use case whenever we want to embark on a project. So what happens is that when you have this data, you could have actually chart out a real-time linked data space. When people start collecting a large chunk of data, you store them in a CSV file, right? And then you pull some analysis model, and then the moment you have your data sets, it's much easier for you to play around. You can test a lot of techniques, play with the ML techniques, right? Do some classifications, and you can see the anomaly detections, right? So a lot of things can be done, especially when you have localized archive data. But the issue is that in research, normally we depend on the third-party public source data, right? So it's high time that we should have our own data sets. So this is an example of a product, a consumer product like Nike shoes. You know, like they put up on the sensors in the shoes to monitor the individual tracks, right? And then ability to share the data to the iPhone and iPod, and then can also post messages to the Facebook account. Okay, so this is just an example. So like wearable devices, as I told you that it's very important enabler for consumer-centric IoT. Current focus is very focused on healthcare, right? Fitness tracking and sports and so on, fashion, but nothing more than that. But eventually, there are a lot of things that we can do with this wearable. Okay? So, for example, if we have agricultural farm, right? Agricultural farm could be any farm, any crops, and let's say you design a wearable shoe for the farmer. While the farmer is working on the farm, indirectly the farmer is collecting some data because he is wearing a wearable shoe, right? So while like he walks, he picks up the crop, you do something, indirectly he's actually collecting the data from the farm. Rather than have an isolated systems, you can utilize the wearable concept, right? So what happens is that preferably in agriculture, we have like soil management, like we want to measure the soil status, moisture, right, the temperature and so on. So this could be one good use case. So likewise, wearables can be extended to many domains. Not necessarily has to be like, you know, when you want to create an IoT system, it has to be isolated, right? So this is like an example of another further example in agriculture, like you can use wearable shoe to have a proper instrumented field, then you can integrate with various nodes and put some drones for imaging, okay, nothing more than that. And of course, you have your own cloud service to archive the data, right? So these are some examples of IoT products, right? To be surprised that these products are not by tech companies, they are created by fresh graduates. Fresh graduates who are actually in the final year and then they move on to form a startup. So what happened, like Nest Thermostat, it was actually by a startup, then it was bought over by Google. So likewise, many products for IoT is actually by startups, not tech companies. Right? So the market is still there, but is that we need a unique use cases. So the elements is like the industry is hyping, but we need to know what the consumer wants, how does it connect, and then what type of intelligence, and can the consumer trust the device. So this is basically the design flow. You have the concept, the high level design, okay, component level analysis. Okay, that's basically a typical life cycle, right? But today we are lucky because we can skip most of them. We can straight go to the productions and then release on the documentations because everything is there. So there are three fundamentals. Of course, first you need to know the way you want to collect the data. Then how do you want to process? Are you going to put some event-based or rules? Or are you going to put some AI infusion into that? And then finally, what do you want to control? And how do you want to control that? Okay? But it's not that easy because we are dealing with heterogeneity. Because you're dealing with different kind of sensors, different kind of actuators. And then you need to manage large number of nodes. For example, that you're talking about putting up 1,500 to 2,000 sensors under the bridge. So how do you manage that? How do you discover them, right? So processing them, right, of course, we have a lot of MUs today to do that. And then standardization efforts. It's also important that normally in academia, we rarely looks into the standard documents. But it's very important. Of course, in industry, they will look into the standard documents for their product release. But for us in academia, it's pretty much important because that's the way you know what is the recent outcome. What would be the recent standard into the products. Okay? So there are lot of challenges today, like, of course, large-scale corporations, dealing with heterogeneity, and lot of device unknown configurations. So this is what we call as the need for interoperability, right? So interoperability is the mechanism, how do you make those devices to talk each other, right? So, because why we have this issue? Because of the heterogeneity. Different communication protocol, different programming languages, okay, different hardware platforms, right? Then different OS, different databases, right? So today, I think those days we used to talk about SQL, but today we talk about no SQL because we are dealing with unstructured data. So it's coming up like MongoDB, right? So different data representations. So all these points to the bottom of interoperability. But not to worry, because interoperability can be solved in many layers. And when we discuss about interoperability, there are 7 layers of interoperability that we need to discuss, and probably we need another talk to talk about it, right? But just to give you some hint why interoperability is important, right? So I just go on the key components that we need to understand. So like everybody, any students or any faculty members who wants to begin project on IoT, you just need to pinpoint on these 5 components. The first is the power and storage management, security and privacy, microcontrollers, sensors and actuators, and connectivity. So if you're talking about power and storage management, we expect that would be billions of devices, but it's just a prediction. It's not exactly happening now. But of course, when you talk about volumes of devices, there could be a staggering demand for power, right? So here we should actually leverage on ultra low power design, probably use renewable energy like solar, which is very good avenue, right? So engineering students who are actually working on engineering projects should actually look into this kind of avenue, especially on renewable energy. And then storage management. Of course, you know, all the data that we like to push into the cloud. But remember, whenever you have wearables are most likely your personal data, vital, very sensitive data. And nobody wants to put that in the public cloud. So this is high time that you should look at something that can aggregate the data in local storage within your control. And you have access, you're the only one who have access to it. Let's say if you have healthcare data and it's available publicly in the cloud, and one day there is data breach, what would happen? Your healthcare data is actually exposed, right? So these are some important considerations for IoT ecosystems. So this is the first component. The second is, of course, security and privacy. This is a never-ending problem, right? If you look at security, it's always there's something coming up, right? Because every time there's a new technology, there'll be something, some breach and something that we have to look into. So talking about Internet of Things, we know that IoT characterizes data-intensive environment, and you know a lot of data is being around. So consumer like us, we only accept the device if there is privacy assured. So domains like security and privacy can be very important for Internet of Things. Okay, how do you encrypt your device? How do you encrypt your applications? Can be very important avenue for Internet of Things. And then microcontrollers, I think probably a lot of us today might be well known about the availability of the open source hardware today, which enables us to experiment with any projects easily. Gone are the days where you need to have a specific boards, you know, specific hardware which can be pricey. But today, like because we have like smart objects like Raspberry Pi, you have an Arduino, Galileo, BeagleBone, you can just buy them off the shelf and try to experiment by yourself, right? So, and then if you're going further higher, there are also more specific high-range hardwares for IoT, right? Like Pinocchio, Udo, which is, they have a larger processing, right? Power, larger processing consumptions, better memory spec, and these are we talking about some specific IoT projects that you need some specialized hardware, right? So these are some of the bespoke IoT boards, not common in the market, but it's available, especially for example, if you want to calculate the search engine optimizations, for example, then you can use this kind of board. Okay, then talking about machine learning hardware, which is now the trend, right? Especially when you have AI, generative AI. So you are talking about the NVIDIA's, okay, they come up with a different chip type, different cloud and edge platforms, which could be pricey, but it's a growing trend. And you see many countries actually now embarking on GPUs, okay? Because you're talking about massive data, and then you're talking about generative AI. Definitely you have to embark on this specific bespoke ML hardware. So the fourth is actually familiarizing yourself with the sensors and actuators. Whenever you work on an IoT domain, you need to select the right sensors, right? If you're looking at oil and gas, there are different set of sensors. If you're looking at agricultural, there could be a different set of sensors. And they don't mix and match. It has to be very specific. So this kind of knowledge, you can only get it from the standard documents, not from the textbook, right? So sensors are important because they are needed for gathering data and measuring data, right? And of course, actuators needed for actuation purposes, right? So today we have cheap and compact sensor technology off the shelf, which you can just buy online, and then try to experiment this with a small use case, right? To get started, right? So if you're talking about air quality monitoring, you can just buy air quality sensors and the temperature sensors and start a project on indoor air quality monitoring. Again, then the connectivity, the fifth component, we know that IoT crosses a broad range of data rates. So today, Wi-Fi might not be a viable option, so we started to look into other protocols, like Bluetooth for low energy, BLE, right? Those days, Bluetooth used to exchange contacts, images, but today, Bluetooth can be a connectivity, right? Because it's separated from your enterprise networking, and you can use specifically for that. Okay? So there are also other options, like Ethernet, Wi-Fi, Bluetooth, and so on, okay? And there are different consortiums work on it. So don't worry about these networking protocols because they are expanding, they come and go, right? So this is a generic use case on IoT, smart homes. But as I said, smart homes might not be a valid use case for many countries, right? It depends on the local social context, okay? So these are some first steps, right, for IoT. We have to look at the device platform, microcontrollers, right, software for device API, connecting and networking, server and programming, cloud platform, and of course data analytics, visualization, and machine learning. So the step 1 to 6 is fundamental, is already available, and it's very easy to follow. The only focus is step 7, because you need to find the right algorithms that works with your domain, right? Machine learning is very broad, right? So today, if you write a paper on deep learning, you have to be very fast because the moment you finish up writing the draft, somebody else will be publishing it. So that's one, I would say a drawback or maybe disadvantages for the computing community, right? So because it's catch up very fast. The moment you first finish your first draft, then somebody else already publishing, right? So what will happen? The implications, like we expect that leading edge company will start use IoT to gain competitive advantage, right? And we'll expect there are more horizontals and verticals in this area, rather than talking about everything smart cities, smart home. There could be other use cases, right? So, for example, forest fire detections, even river water quality, which is very sustainable, right? These are sustainable use cases. So we used to see use cases on smart homes, smart cities, and so on, but which are very urban centric. But now the paradigm shift is towards sustainable ecosystems. So academics, researchers, you can actually start on the real problem. Probably can start in the campus itself. Probably you can do something on waste management, something right in the campus. That could be a great experiment, right? So these are some use cases like where they use in Australia that like the safety helmet has been integrated with both IoT and AI. That actually this AI will tell us what job to be done in the real world. So this some generative AI is being used to create prompts for the workers to assign them the job to be done in the task, right? So likewise, there are many other use cases like wearables for workers and so on, right? So like in logistics, right? In the campus, like for example, facility management to control the cleaning, right, and maintenance resources. Okay, this is in University of New South Wales. So like us, like many students or even researchers, the common mistake we do that when we develop a project, we want to add some functionality that is not relevant. So we have to avoid that. So I think if you look at Google, if you heard about Google Glass when they launched was hype. But the project, the product wasn't really successful. Not because of the Google Glass is not a good project. It's a nice project, but it's not meant or relevant to the consumer. So the Google Glass is didn't fail because it wasn't clear to the customer what problem it solved and why they needed it. Okay? So likewise, we have to be very careful when you develop your use cases. So there is, of course, drivers and challenges. Drivers, we have all the resources today, from the sensors, chips, and so on, and you have a better connectivity. The challenges is how you deal with the data, of course, the security, and very importantly, the cultural part, the skills and the business process, which is relevant, right? And of course, make sure that whatever we develop can compromise with the existing system, the legacy. Otherwise, it's going to be a waste of investment. So the prediction is that, organization will try to tell us, but down the road, consumers will be attracted to applications, especially. Consumer will buy things that connect, and consumer will keep the device they can trust and they feel safe, right? So these are some takeaway, like there are no proprietary solutions, right? The past decade, and today we see a lot of proprietary solutions, but in future we're going to see more open source kind of things, and more likely more new standards, and which can help boost the consumer-centric Internet of Things. So these are some resources on the protocols. Okay, basically on protocols. Okay, on the for the Internet of Things. Some references that I used for this talk. Okay, and that's it. Thank you. So I'll feel free to ask any questions if I can spare some time. Okay, good question. But it's not because of the cost. It's just the applicability. Because if you look at the social context, basically in Southeast Asia, we don't, our interactions is beyond that, beyond our home, beyond villages. So it might not be like, if you look at some cold countries, right? Normally they have to spend, like winter season, they have to spend a lot of time in the home, right? So that, in that sense of point, that will be applicable for them, but not for Southeast Asia. Cost, those days, yes, but now I think it's not an issue. Like, you can just buy off-the-shelf sensors and you can do your own home automations, right? You mean the consumptions? Yes, yes. So I think I pointed out about the renewable energy, right? So like if you have like a solar-based, self-charging mechanism, then you solve that problem. It doesn't depend on that, the consumption. So, but the awareness, like you say, the awareness is not that much. But I think now people start to realize the importance of renewable energy. Okay, sustainable IoT, like if you can develop like solar energy based device powered for probably for river, for any plant monitoring, that would be like you can save a lot of cost sustainably, because electricity is all about tariff, the billing, right? If you can bypass that, then it's okay. In some countries, what's happening now, electricity boards, now they are encouraging the consumers to install solar panels, and then they buy the power from the consumer back. So that's happening also. Okay.
Thank you, sir, for your valuable inputs. It has definitely thrown a light on all the IoT-related concepts to all of us. So we gained more knowledge about these topics. Thank you for that, sir. Now I request, now I request Dr. G. Vishnumurthy, Dean CSE, to felicitate the speaker.
We can break for lunch. All the students and participants are requested to join after lunch at 2:30. We'll have one more keynote session. The registered participants will be having lunch in the first floor of E block, and the students will be in APJ Kala canteen. All the participants and the students are requested to come back by 2:30. We'll be having the session at 2:45. From Anirban Pal, sir. Students are
छैया 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 चल छैया 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 चल छैया 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 चल छैया 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 चल छैया 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 चल छैया 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 सारे इश्क की छाँव चल కల్ కళ్ళు మంటూ కంచి కట్టి చిందు కొట్టే జగమంతా छैया छैया check. Hello, hello. 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 Hello.
Good afternoon, everyone. I request all to come and occupy their seats in the auditorium as the session is going to begin. We are honored to have Mr. Anirban Pal, Principal Enterprise Architect, BFS North America, Tech Mahindra, to deliver his keynote session on deep learning applications. Anirban Pal has completed his bachelor's degree in Computer Science and Engineering from MS University, India, and MS in Software Engineering from BITS Pilani. He is the university topper in the year 2004. He has experience in enterprise systems, cloud enablement, architecture and design, performance engineering and QA, AML, education and training on tech and behavioral skills. He is the recipient of several awards. He received Best Young Talent Award for paper on Artificial Intelligence and Neural Networks. And he is the award winner for Petrotech 2003. And he received a CSE award for contribution in engineering excellence. He is a speaker at several national and international conferences. He is a certified IBM Cloud Architect, Microsoft ASAP Architect, AWS Architect, Agile Coach, Scrum Master, and working on GCP and Azure certifications as well. We welcome you, sir, to deliver your keynote address.
Thank you, ma'am. Am I audible? Thank you. So, hearty good afternoon to all of you. Thank you. That's some nice energy. Post lunch, it's always difficult to conduct a session because anybody can become better than your mothers is putting you to sleep. And I have the responsibility of trying to not be your mother. In case I'm boring, please give me that feedback. Yawn. But show me that you're getting bored. Otherwise, I'll try to keep this minimal coding, minimal mathematics. I think I got some feedback from what Professor Samin told this morning. So I'll keep that dumbed down. Nevertheless, there is some elementary things that we will expect my audience to know. That being said, let's straight go into the topic. You know that the talk for today is on deep learning applications. And whereas Professor Yagna Reddy in the morning did mention that he doesn't even believe deep learning networks are deep, or for that matter, they are learning. Because learning is what the human intelligence does. And no AI technique that we have invented as on date is really capable of doing the way which is called true learning, the way human brains and neuron cells do. As you all know, we are a collection of 100 billion neurons making connections with the dendrites into other neurons, not in one dimension, but in up to 9 raised to the power 9 dimensions per neuron cell. So you can imagine the scale of 100 billion such neurons doing. In that sense, nowhere is AI or artificial intelligence's disciplines anywhere close to all of the neural connections that adaptive learning can do in biology. Nevertheless, today's talk is still going to be on that same topic. What took 500 to 700 million years to emerge, after the last 15 million years of evolution, did not change. And what is it? Can any of you guess? And it's related to that image out there. One of Euglena, that's right. What is the Euglena's speciality about unicellular organisms? Okay. Clue? It is the first organism that had the capability of photoreceptor cells. And if you look at it, that is made possible by something called as the protein opsin and melatonin. This is a simple protein that first emerged sensitivity to the electromagnetic spectrum that we today call as visible light. And at the same time, in advanced organisms, the protein only just slightly changed and became, melatonin, which in turn gave a little better sensitivity to light. So if you look at it, this little piece here, that's the photoreceptor parafragilar body, which first recognized. And in the remaining 15 years since, all animals in the animal kingdom have evolved sensitivity to various parts of the spectrum, which was the last part of the spectrum that, mammalian organizations and all of us, all organisms that we know of, got sensitivity to. Can anyone guess? Apply your basic physics and it'll all be fine. Which color of the spectrum did human beings, for example, see last or most recently into the past? It was blue. Other colors of the spectrum, if any of you have been to any of the major museums of the world and if you've seen ancient human paintings, not the ones which are built by modern European arts after the Renaissance, I'm speaking of ancient paintings, you will see they never had the color blue. And that explains why that sensitivity has changed. So today's topic is all about that. Among the many applications of deep learning, you heard a few of them this morning. Everything from self-driving automobiles to medical imaging to large language models, predictive, prescriptive, descriptive, artificial intelligence, and all their applications. We are today only going to focus on a very small part, computer vision, and that is what we will talk about. By the way, if anyone can guess, whose eyes are these? This is someone's eye or something's eye. Whose eye is this? Anyone wants to take a guess? Human eye? Yeah, okay. A little more reasonable guess would be maybe a female gender eye. You wouldn't call that a male eye for sure. Anything else? Okay. You all said it's a human eye. Now, this is where comes the surprise. You're all wrong who thought it's a human eye. It was created by ImageGen. It is no person's eye. And as you all know, ImageGen is a generative algorithm. And that generative algorithm generated that eye image. So realistic. That's where we are going today. And the human brain, as you all know, can process images, visuals, much, much faster than text. Up to 60,000 faster than text is what modern research tells. We'll never be sure. But it needs us to understand how we, human beings, see vision. Biologically, emotionally, physiologically, as well as in our sense, in the computer science, mathematics, applied mathematics language. In the mathematical sense also, we need to make sense of vision to be able to replicate it in computers. If we can't do it, if we can't do the abstraction, it's difficult for us to convert it into algorithms. And you, all of you, researchers, authors, students of the future, understand we need to take that cue from biology. Let's see how we read and let's understand that a little better. Reading. Now we're only focusing on reading and visualizing, the two different aspects of vision. So anyone, I need a volunteer who would say that they can read. If your eyes are good and you can read, please volunteer. Anybody? One? Yes? You're raising your hand. Get up. Go ahead. I will request you, please feel free to read the text in the blue part of the screen. Can you read it for me? Loud. Once again. You see, the second time, when I said once again, something struck him and he read the second the. There are two the's there. For those of you who've still not understood, you see there are two the's. But the first time around, most of us didn't notice it. How many of you noticed it the first time? Raise your hand. Good observation. And for the most of us, we didn't notice it. You see what human brain does? Thank you, please. Please have a seat. For most of us, what we really do is we don't read every single character or every single word even. We read what is called as scan boundaries. That's the way we read. Especially when it's text, any language, we jump scan boundaries. Our brain is making mathematical calculations and assumptions about a lot of things. based on what it already knows. You see, where am I leading this to? What are large language models doing? They're doing the same. They're making a lot of abstractions based on enormous data sets they've seen in the past, which is where I would very humbly, though I'm at an age where, my age is experience of Professor Yagna Reddy, his viewpoint versus what I am sharing here is, there are some similarities in the way we do artificial neural network learning when it comes to visualization and computer vision. It's not very advanced, not the way the human biology has evolved, but that's 15 million years in the making. And in the last 20 odd years, and very particularly in the last 10 years is where, and I'll come to that as to why. Computer science is at a stage where we are data rich, we are computation rich, and the sweet spot between them has helped us to go beyond what we call as the limits of erstwhile sciences. The sciences of artificial intelligence, the sciences of computer vision, they were known not now, 40 years ago. They have not changed much. But the application of those sciences is happening today because of that sweet spot. Enough data is available, enough computation power is available, we are now bringing them together. When I was in college 25 years ago, when I was in your place, we would talk of layers, neural network layers, no more than 3 layers deep, and each layer going no more than, in some of the most advanced models, 500 neurons per layer. Even that was impossible computation. It would take several hours, if not months. Today, even our phones have better capacity than that. Many of our phones have better capacity than that in computation, which is where the sweet spot has come in, where we need to understand vision much more deeper. Do we know vision? Do we know how we see text? Do we know how we see images? And very clearly in this example, the image of the park, the pond, and the tree attracted our attention more than any of the text did. So my agenda of the talk today, which will last about 60 minutes, and pardon me for that, is going to be about the what of vision, and particularly computer vision, the why of computer vision, the motivation behind this talk itself, the when, where, who applies all of this vision, whatever we're talking about, and more importantly, I'll focus on the how. How do we do analysis of images? Very particularly, I'll take one small fragment of the problem, classification problem, because I can't cover everything in a single hour. And then from there, we'll go on what are some of the advancements in the field. To begin with, prerequisites, like I said, post-lunch, might be sleepy time, give me feedback. Keep giving me feedback, participate as much as you can, and I expect you to know basic of artificial neural networks. Anyone here who does not know, please raise a hand. Those are the prerequisites for you. Understanding what is an input vector, understanding what are the weights in a weight vector, understanding how the input and the weight vector goes to a summation function and then to a activation function, and then linear activation, non-linear activation, understanding the difference between the various non-linearities, sigmoids, based on tan H or ReLUs, understanding these basics, understanding what is the loss function in a multi-layer perceptron. It's all feed forward, but you also have a back propagation, knowing how the back propagation gives feedback to the network on learning what is correct versus what is wrong, and how much is the difference, and the difference calculated in terms of different differential functions, variance being a very popular norm. And there are various ways in optimizing them and the parameters, understanding stochastic gradient descent, understanding descent optimization in batch normalization, regularization functions. So I'm expecting that you know those basics. That's what I've been given to understand. So I'm expecting if you know all this, if you understand what this is, and if you understand the mathematics between this piece, this piece, this piece, and this piece, you're good. Anyone who does not meet that requirement, do raise a hand. I'm hoping you all know. If you don't know, it's absolutely okay. Not your fault. My fault of making a wrong assumption. But I'm told that you know it. All good? Fine. So we will assume that you all know what a fully connected layer is, and you know the various hyperparameters and tuning, and you all know any neural network is only as good as its training data set. No matter what algorithm you write, if your data set is bad, your outcome is bad. And therefore, we need good data sets. We also need to understand in, unsupervised algorithms how the data set gets split up. You will have a labeled data set through which you put the program during training, the training. Then comes another data set, the validation data set, to evaluate the hyperparameters and optimize them. And then comes the test data set. a data set that is blind fed without the labels to see if the prediction happens right, till you reach your level of confidence. If the level of confidence is reached, you know your network is good. Example, one of the popular examples in open source, I'll take it. You know the cats and dogs case study, right? A lot of images of cats, a lot of images of dogs, and we're not, a lot doesn't mean a few hundreds. We're talking of few hundreds of thousands. And then what do? We split the data set, we put them through the logic of your network, neural network algorithm. It then classifies, is a random given image a cat or a dog? It may be neither also. You can always take a train image and ask it to classify, and if your network has been taught only to image classify between cats and dogs, unfortunate, and this is where I say, it will still go and classify it either as a probabilistically cat or a probabilistically dog. I don't know which train engine looks like that, excepting the ones in maybe the children's parks and Disneyland. None of them look like cats and dogs, but that's the level at which our current levels of artificial neural network with image vision and all those advanced algorithms resides. However, with the advancements in IT today, we can classify not 2 or 3 categories. Our classification capabilities have increased to millions of capabilities. So millions of categories can actually be classified in the output layer. You can imagine then the previous hidden layers and the input layer, how complicated they can get in terms of the output layer has million nodes to actually classify out. So that's where we are, and we expect that this part of the understanding you already have. It will be good if you understand some of the other things that were talked of this morning, sequential, attention-based networks, LSTM, long short-term memory. If you know that, good. If you don't know, no problem. Important things to know about the advanced image vision networks today, typically for computer vision classification, are based on ResNet. The most modern apps and all of the most modern algorithms are based on variations of the ResNet, but generally ResNet. And then last year's publications in most of the popular conferences was with some new models, which we will not talk about today. It's way beyond the level of complexity that we are addressing today. So with that as the prerequisite set, let's move on. Your questions are welcome, but I will request you to please keep them till the end of the session. I'll be anyway available around in the conference. You can also meet and ask me questions later on. So for those of you who want to reach out to me on social, those will be my whereabouts. Power corrupts, and pointed power absolutely corrupts, and I am on a PowerPoint. I'm restricted to a PowerPoint today. I can't show you a live coding demo. So please bear with that PowerPoint thing. There's a lot of concepts in my presentation. They are concept heavy, but I will keep text in very minimal slides. I'll use mostly images and graphics. And because a picture talks 1,000 words, I'll also not show you code unless you specifically need. If you need code, meet me offline and I'll show you links where you can get some of that. That being said, what is vision? We all know. Stimuli from external world in the form of the visible spectra. Whether you consider the visible spectra natural spectra, red, blue, green, or whether you consider it as the modified natural spectra, CMY, and for those of you who are new to CMY, CMY is basically cyan, magenta, yellow. That's also a set of colors that can be used to generate all of the other possible colors. So whether you use additive color scheme or subtractive color scheme, able to take stimuli, convert that stimuli into numbers. Whatever numbers, numbers based on color intensity, numbers based on brightness, numbers based on contrast, you convert them into mathematical numbers. And then, based on the gradation, create greater and greater effective sensations. How do our eyes work? We accept visible stimuli in the form of light. Light is a spectrum of colors. Certain spectrums create more implications, some of them do less. But ultimately, remember, the eye, many of us believe we see with the eyes, but is that true? Is that true? It isn't. What do we see with? Brain. That's the beauty. Eyes are only the pinhole camera. Or, pinhole camera is a very weak abstraction of it, but that's what it is. It's just taking the stimuli in. But the conversion into the stimuli via the optic nerve going into the visual cortex, first it goes to the thalamus, and from the thalamus it goes into the visual cortex. The visual cortex does enormous mathematical operations inside it. We don't know them yet, and that's the truth. But we're trying to learn from it. We're trying to see how the brain works and then make near approximations. And all of that is based on that stimuli. So the discipline of being able to convert what we see in real vision, in biology, and slowly move that into giving computers the capability, the ability to recognize patterns, to recognize contours, to recognize movement, to recognize specific objects. This is a chair, but that is a person, a female person. That is a chair, but that is a gentleman. How do I make the distinguishing of objects, object boundaries? And then it's a continuous stream. It's not a stagnant point like a snapshot or a click camera. It's like a video. And the video in front of us is continuously moving. But we are able to identify every object. The moment I say, here's my hand and here's the pointer, none of you can see the pointer, but your brain knows, it has done the calculation, the pointer was in his hand, but the moment he's taken it, depth comes into field because of the binocular vision. And you know the pointer is hiding behind. So teaching these things to the computer, mathematically, that's what we're going to talk about today. Without the mathematics, of course. I know I don't want to bore you much. So that involves this simple schematic. If you can look at that schematic, it involves some kind of pre-processing so that you reduce noise and you do the right color stimulus generation. Pick up areas of interest. You do abstraction, you do contouring, you do feature recognition, and once that is done, once the feature extraction is done, then comes actual processing. The actual processing of all of these features to create what is called as a complex collective whole. And that is where object recognition and feature match comes. You remember patterns in memory, the sulci and the gyri of the brain. Those patterns of feature mapping, for every object that you can recognize distinctly and remember, they then start creating picturizations of the real world. And from that then comes the advanced aspects of, I saw vision, what do I make of it? Is it helping me to, let's say if you're playing a game, catch the ball in the right angle, in the right speed, in the right velocity, make the right jump? Or if you are playing the bat, use the right moment, the right stroke, the right guesstimate of the ball's trajectory. Or if you are maybe in your home swatting a fly or a mosquito that's biting you, that also needs the same level of calculations. It's all happening instantaneously in the human brain. How do you teach it to computers? We're not good at it yet. Believe me, you don't have a robot that can swat a fly. And if you really want to create a research paper, yes, authors, you're welcome to. How applicable is it in terms of commercialization? No problem, but that's still a good algorithm because it is estimating the trajectory of a moving body whose predictability is based on how well you know the movement of all other such mosquitoes and flies of the past that you have seen. You see, it's mathematics there too, but the brain is instantly doing this spontaneously. You don't need a research level, paper in AI and computer vision to be able to obviously understand how to swat a fly. Anybody can do it. Even monkeys do it, by the way. Okay, so coming back, we need to be able to do things like motion analysis, matching, and then flagging events. What events are useful, what are not, what is my focus of concern, what is not. Remember that it was not on his focus because it was noise. But how do I do that with computers? That's important. So the camera that we call the eye, which is responsible for vision, is not as important as the rest of the stuff. Excuse me, please. Pardon that alarm. All right. So going back, we need to convert from stimuli to basic colors and brightness and identify them with filters to simplify the complexity of the wavelengths and frequencies of electromagnetic spectrum that you're receiving. And then between those frequencies, the simplification will start doing things like approximations, generalizations, extraction, feature extraction, boundary analysis, from which it will go into texture, contour, depth, and from that it will go into identifying objects. This cycle, if you think logically also, you don't need to have a research paper in optics or visualizations. This is pretty common sense. But doing this little common sense is actually an enormous amount of mathematical complexity when you want to represent it in a simple model. And that comes from the human brain. So what all are we doing? We're doing shades and shadow. We're doing patterns and distortions. We are doing generalizations, approximations, optimizations. We are doing abstraction. We are doing exception handling with the generalizations. We are doing overlapping and depth, understanding the depth of field, how much wideness of coverage, and the depth of view. What is one behind the other? Along with that, something that we are not going to talk about today, the identity and memory. Having done it, we are storing it and we are remembering it. And then next time around, we are applying patterns and matching to that stored memory image, which is helping us gain vision. And all of that wonderful magic is happening there, right there within the human brain. But there's so much more that we still don't know. Let's be very honest, let's be humble, and with all great humility, let's know that there's so much unknown. So the field of AI, computer vision, and all of those deep learning algorithms that you're learning, you're researching, or you're writing about, we are maybe at 1% maturity. There's 99% we don't know. And that is where the scope of further exploration is so much more for all of us. All right, so that being said, the three things that today's talk will focus on will be how we do approximations and optimizations, how we do abstraction and extraction of features, and how do we use that to gain classification. What about the others? They are important, but we are not going to go into that in this talk because I don't have the time and I don't have the wherewithal to go into all of that today. So let's see how the brain is wonderfully doing all that. But before we go into that, why are we discussing this? What motivation have we as a student, as a teacher, as a faculty? Why computer vision at all? Now here are some of the standard applications of computer vision and the need for computer vision today. In a research study that was done, and this is like multiple organizations, it was found that internet-based commerce found more than 720,000 hours of video that gets uploaded daily, and the number is increasing by the hour. The amount of data in the video streams only is no longer in petabytes, it's in exabytes. Next, images. 650% of improvement in engagement, your viewer engagement, happens when your website has images versus those that don't. 3.2 billion images are being shared online. And contributed to that, remember this number is all of us here. Every one of your Instagrams, your Snapchats, your Facebooks, along with all those business images and research images. Everything is contributing to that. It was found that even in organizations, enterprises that did studies, employees were, possibly liking to communicate with video and images rather than text only. Any of us know, go back 10 years and look at your IMs, instant messengers versus today's IMs. How many of you would use any of the older ones? Nobody. That is where the age of the internet and data today focuses on visualization and why we are discussing this. But when and where do we apply all this? Where is it really impacting us? What are some of the practical applications? So here are a few. In business and in commerce, retail industry is using this in a big way. Example, hotels and restaurants. Any hotel and restaurant website you go, you get a look or feel of what you're going to get. Only then you select it. Whether you go there through Yatra or TripAdvisor or wherever else, you're always going to look at and then only accept something. Restaurant, hospitality industry, medical imaging. Morning you had a few examples of the speakers talking about how it is helping. Everything from recognizing whether you have a medical cardiac condition based on your eyeball. Retinal scan is telling you how your heart is performing. Versus actual images of things like tumors, things like cancers, things like blockages and clots. They are being analyzed not by human doctors anymore. Various radiological X-ray scans are being passed by AI algorithms. They are making a guesstimate of what the medical condition is and then being referred to an actual human expert. Next, all of us know, and this is hyper hyped, not just hyped by the media, automobiles that are self-driving. It's a reality today, but how much of that reality is really translating into fully, automotive driving? We know it's quite restricted at this point in time, but that's a major application and implication for all of us. Video tagging, especially for security applications, an emerging field in computer vision, not very up to date because the algorithms are still not there. Example, many of us have CCTV cameras in our home. But let's say you have an incident, whether it's in the college, whether it's in your gully, or whether it's inside your home. Let's say there's a theft or a burglar. What do you typically do? You have a CCTV installation, what do you typically do? Do you precisely know where to go and look at? Oh, on the, 3 a.m. to 4 a.m. in the morning at 3 and 15 minutes and 20 seconds, the burglar came. Is that what you do? No. You scan through 3-3 hour slots of videos or 4-4 hour slots of videos, or however large your CCTV system is storing each chunk as. This is where video tagging and security identification of events and incidents is a very important area of research. The algorithms are not very firm today. We only have about 85% approximations there, no better. And I'm speaking of the best research firms. So there's a lot of scope here. Other areas, important thing for many of us students is exam proctoring. Many of us are taking online exams today, and exam proctoring needs a human being to sit and monitor. Are you cheating? Are you asking the neighbor? Are you referring a text? Or have you written, chits on the wall? You don't need a human to do that. Such a boring job. Imagine I were the proctor and you are the student, and I have to monitor 100 students a day who are taking examinations, and I sit and I have to monitor whether you're looking here and there. Such a boring and unfruitful job. That's an important area where today AI can help, computer vision can help, and we should possibly be looking at more applications there. Of course, things that are pretty mature, defense and space exploration, process monitoring, especially in the food processing industry today. Monitoring whether the food is in the right context, in the right texture, in the right cooking, and if not, moving it out of the production line or changing the processing. Fraud detection in banking and financial services, a very major thing. There are so many AI models of financial fraud detection. Some of them are based on transactional data, but some of them are very critically based on direct computer vision. Examples. When you are doing online cards, you typically do cards based on a digitized token. Tokenization is one way of using online cards. But then there are applications where you can just scan your card or just give a image copy of the card, and based on its BIN number, it will connect with your bank or your issuer system, and it will do a credit or a debit, depending on the nature of the transaction. A lot of that needs the validation of the card against the image database, which erstwhile was not possible. But today, it can happen in that same 150 milliseconds. Remember, a transaction that doesn't happen in 150 milliseconds is flagged off as a failed transaction. So doing that needs greater improvement in our computer vision algorithms. Now, here's a practical example which I just picked up from one of the popular websites. So this is a real practical use case. To be able to build a rich online catalog, especially if you're in the restaurant business, where thousands and thousands of images, or if possible millions of images are available, but you have to caption the image. Here is some captioning that has happened. If you watch there, a glass of milk and some cookies on a black table, some pancakes which are with a glass of milk on a black table, some grapes and a glass of milk. And you see these captions below. I know, pardon me, it may not be visible to some of the people at the end, but I'll kind of zoom it in for you. So is it more visible? Now, these captions are not human written. These are all computer generated. So automated image captioning is one of the major things that restaurants do. But look at the preciseness and the accuracy of the model, along with not going into false positives. So here are cookies and glass. Here is also cookie and glass. But this is on a wooden table, and this is on a black asphalt platform. And you see that it very clearly mentions that. This is the level at which our algorithms have already been evolved. This is automated image captioning, something that can be used in multiple places. But this is the motivation of the business side of things. Academic research, definitely important, improvising your sciences, but then also improvising on the application of the sciences, because that's a full cycle. You need research funding, and that research funding will again come from business applications, which is where there are so many areas of scope where, as academicians, we have to contribute to this part of the problem statement. Now comes the crux of the talk. How do we do this? So how computer vision works, let's take a cue from what we discussed just a little time earlier. How does human vision work? We saw that. Let's try and abstract those elements into mathematical models and techniques. So can any of you suggest what are some of the models of standard computer vision? Okay, very good. But what are the kind of networks you generally use at the very beginning? Very good. Convolutional neural networks, nice jargon, but For those of us who don't know this, I'm going to decipher it. How many of us are exposed to convolution as an operation in mathematics and the application of it in AI? Raise your hands, please, if you are. Okay, wonderful. A few of us. For the rest of us, let's quickly take a deep dive into that. So artificial intelligence, as many of us already know, is possibly going to be, in multiple dimensions. I know some of you may agree, some of you may disagree, but this is how I would put it. If you take all methods of AI, expert systems, all kinds of networks, neural networks, all kinds of generational AI, all kinds of generational algorithms, all of that is AI. But neural networks is one small part of that. And within that, machine learning is a subpart of all kinds of neural networks, with deep learning being the primary scope where we will talk about computer vision. But what is deep about deep learning? Not deepness in adaptive learning, but deepness in the number of layers, precisely that much. And the depth of layers is not necessarily fully connected. And that is where we will come in. Fully connected depth, we all know, will bring the problem of exponentiation. And the problem of exponentiation at some point in time will become computationally infeasible. So how do you reduce infeasibility computationally? That's what is the whole discipline of CNNs, which computer vision will deal with. So we are going to discuss only this one strategy today, CNNs, and we will see some of the advanced CNNs, VGGNet, AlexNet, LessNet. If we have time, we will go into them, otherwise I may not. We'll just learn the convolutional piece. What are CNNs? How do they work? And how do you optimize a CNN? Large language models, Gen AI, I know is pretty exciting among the folks today, but that's something that we will not go into. Though some of the applications of computer vision will overlap with RNNs that are used in the LLM models. But we are not going there today. All right. So going back to nature, we already saw how we see a cat, the camera of the eye creates an image in the visual cortex, neurons fire, and it recognizes and classifies it as a cat. And all neurons fire based on the Hebbian rule. What is the Hebbian rule? Anybody? The Hebbian rule states neurons that wire together fire together. If they connect with each other, they will fire together. So you think of a rose, the moment I say rose, what does it mean to you? Flower, what else? Okay. Many petals, what else? Several colors, what else? Smell. You see, several different dimensions are all coming into the single word rose, and this conceptual meaning comes from that multi-dimensional vision. We're not going into that level of multi-dimensional vision. We are only going into the spectral part of the vision for today, when we are doing what I call as the AI-based computer visions of today. Now here is an example model. Imagine I were to take, these are some radiological scans of the human cranium, the brain basically, and I have to convert this complex array of millions of images, medical images, simplify them in a certain manner that I can extract specific features from each of the images, and those extracted features can then be connected to a input layer of an ANN, an artificial neural network, which then goes through a series of layers. Now what happens here, we all know. To understand this image, the previous one that I just showed you, to understand this image, I'm going to take a little bit of a simplification. So medically, is this representing an infarction, a hemorrhage, or a tumor in the brain? To be able to understood, first I have to understand, how does an infarction look like? How does an hemorrhage look like? How does a tumor look like? Tumor is a excessive growth of cells, infarction is a clot somewhere, hemorrhage is excessive bleeding somewhere within the brain. Forget the technology term, but medically, these terms will ultimately come from inputs that I feed here. And the inputs that I feed there will be simplified and fed into the input layer, as we all know. But how does it really work? And this is how it works. You take any image, you convert the pixels of the image to be fed into a simple RGB scale, red, green, blue scale. But before that, what about the RGB scale? So first let's start with a very simple black and white abstraction. First I'll take one abstraction, simple black and white image, MNIST. Every one of you have heard of the MNIST data set, handwritten characters, thousands of them. We popularly use it for a lot of academic projects. So here is the handwritten character 8, and you see how the computer sees this 8 is I've converted that into a set of values of black and white grayscale. And you can see the more the number goes towards 255, the more white it becomes. The more the number goes towards 0, the more black it becomes, and anywhere in between you have those 50 shades of gray that you can see. All right. So this is about the digital conversion of a pictorial representation of anything, whether it's text, whether it's image, don't care. But you have to convert it into a series of numbers. That's the first part of the problem. We've done that pretty well. Next comes, okay, the numbers have to represent colors. From black and white, we now move to a more colorful image. Now you see certain places have more reds, certain places have more greens, certain places have more blues. So likewise, I have to create an image matrix as a set of pixelated versions by each color. These colors are called, in our technical jargon, we all love jargons, channel. We will call them channels. Every one channel represents a different color. So if you see that same image, wherever there are greens more, you will see green will have a larger number. Wherever there are reds more, you will see red has a larger number. Wherever there are blues more, you will see blues have a larger number. Now that set of 3 matrices, again I'm making some assumptions that all of us understand matrices. We know how to convert a matrix into a vector. If that doesn't hold good, please feel free to interrupt and ask questions. I welcome them. So now, the red gave a red impetus, the green gives a green impetus, the blue gives a blue impetus, and these now start acting as inputs to the input layer of nodes. I've just shown 1, 1, 1, but this is an abstracted simplification. Technically imagine every one of these vectors will become large series of input nodes. Huge number, depending on the resolution of the image. Then comes, once the impetus have been received, that will then go into or propagate through the layers, assuming a standard MLP, multi-layer perceptron. I'm making an assumption that these are all feed forward. We've not yet brought feedback, but as that propagates, you can see it slowly goes around. Some neurons are firing on greens, some are firing more on blues, some are firing on reds, and they are now finally going and identifying, okay, this image that was input is a bird. Now, how did it come to that conclusion? There were weights, and those weights were continuously being adjusted. The weights for every one of these connecting nodes, they were being adjusted till I could train it. But it's not just that one bird, hundreds and thousands of images, and this is where comes in the feedback. The feedback continuously corrects and adjusts those weights little by little till I give a, let's say, 90% confidence that this prediction is right. But remember, it's any classification algorithm will not give only one output. It will give an output on all of them, but as a probability. It's possibly 0.1 dog, it's possibly 0.2 cat, but it's possibly 0.7 bird. And that is telling me, oh, this is more probably a bird. That is the way we interpret and analyze things. This is called a fully connected network, but this has a major problem. And what's the problem? The problem with all ANNs when you do image analysis like this is the problem of plenty. Let's take a simple MNIST image. We all know this will have 784 layers, 784 neurons in the input layer. Why? Because of this image's matrix size. 784 only in the input layer. And then imagine intermittent layer of 15 neurons. 784 times 15 connections. And then that in turn, let's say there are 10 output classes, 0 to 9. Depending on which digit this is. This is the digit 8, so this has to fire. But because there are 10 input classes, it is 784 times 15 times 10. You can see the number of computations that will be needed at every layer. Now add to this the return function, the error function. Imagine the complexity of the operation and the number of operations. And after a point in time, it becomes insane. Which is where the problem with ANNs is to reduce that complexity. We have to first reduce the complexity, and that's what all of computer vision research in the modern world is about. So let's take that bird that we started with, a 1280 by 1024, some pixelations. Given the image size, how many input neurons? Obviously 1024 times 1280. Now 1024 times 1280 multiplied by the second layer. At least 1 million neurons there. This is almost 1 million, another million, and then another million, and multiplied by the number of hidden layers you go. And the deeper the network gets, this number will go computationally infeasible. Which is why the problem is, in a non-deep network, feature extraction won't be complete. In a deep network, you can do feature completion, but computational feasibility will become impossible. We need to reduce, and that problem of ANNs is solved by CNN, convolutional neural networks, which you rightly said. But how does it do it? The simple clue is common sense again. What should I do? If input layer has too many neurons, naturally the problem will multiply. It's a straight multiplication. We don't need any rocket scientists to explain that. So reduce the input complexity. If I can reduce the dimension of the input matrix, everything will get simplified. But before I come to the ANN, which is this layer, the fully connected, FC stands for fully connected layer, ANNs that you all know. But before I come there, I need to do the simplification of dimensionality reduction that happens in convolutional neural networks. So this is the whole thing. Let's take the input matrix, which is an image basically. The input image then gets broken down into small sections that we call these rectangular sections or square sections. These are called, anyone? The input matrix, input vector. That vector gets multiplied by a kernel. Now again, I'm just introducing a new term, but what is a kernel? It's another matrix. Very, very simply put, it's another matrix. But what do I do with them is I do an operation called a convolution. And the purpose of convolution is the kernel identifies some features of this image. So example, if you were to analyze this image and explain it to a baby who is seeing a car and the ocean for the first time, what would you say? Okay, this is a car somewhere on a beach, that is the ocean, and the ocean has the horizon. The horizon is separating the sky from the earth, and this is the sky with some clouds. That's how you'll try to explain it. Same thing you have to explain to the computer. Computer is dumb. But to create that intelligence, you have to first explain those sections and those section divides and those objects and those features of those objects. This happens through operations called convolutions. Convolutions extract features. So that goes down to a smaller matrix. A large matrix goes down to a small matrix. Multiple such small matrices are then using a special technique called pooling. I'll come to that later. Pooling will further compress that into a smaller matrix. And this happens layer after layer after layer. So one convolution, one pooling, another convolution, another pooling, another convolution, another pooling, and so on. And by the way, all of this is only for that one purpose, one, dimensionality reduction. Two, there is another problem, which is basically, in the input matrix, if I don't take all parts of the image, if I only take some parts of the image, remember feature extraction is doing abstraction, so you have information loss. How do you reduce the information loss? And when you go several layers deep, over a period of time, you will have feature loss also. You are not just having data loss. At some point of abstraction, you will start having feature losses. So how do I overcome that? That is the whole discipline of how convolutional neural networks and RNNs, recurrent neural networks, and then later on ResNets, a combination, a marriage between the CNNs and RNNs comes in. So let's straight delve into the aspects of what a CNN does for us. It does three things. Remember what we discussed in the first slide of human vision. Boundary detection, feature extraction, classification. That's what we're going to do. But how are we going to do it? Using the convolution operator. Again, pardon me, one of the slides with text, I promised you I'll have very few of them. This is one of them. So this is how the operation works. The convolutional matrix is basically the output of the channel matrix, which is the input, convert it into a vector, multiply that in non-standard multiplication. This is not matrix multiplication. This is not vector multiplication. This is not cross product. This is a special case of a dot product called the convolution operator, the star operator. What does the convolution do? It takes the kernel and does element-wise multiplication of every element in channel matrix with every element in kernel matrix. It's a elemental, meaning position 1, 1 will be multiplied with position 1, 1, 1, 2 with 1, 2, and so on. And then what happens? The kernel is shifted, called a stride, and we will come to that in the later slides. So this is what happens. And after the convolution multiplication, I do a summation. I do a summation of all the individual convolutional products over every I comma j, which gives me the convolution output. Add to it a bias. Why a bias? Let's say a certain image has more reds in it, or a certain image has more greens in it. So I need to compensate for that. That is where I start adding biases, depending on the nature of the features and channels that we are extracting. Then comes, you have to finally apply a non-linearity function. Any non-linearity goes. Generally we use sigmoid functions where your your initial operators can create a range of values, but if you want specific feature extraction more towards a certain, let's say, specific feature that you're extracting, ReLU operates just fine. So ReLU and sigmoid is what we will mostly see, but again, that varies. We'll come to that later. So here's how the convolution operates. Input matrix, kernel, multiply each element with its corresponding element, then add them all up. So that's how I get this. This kernel was overlaid on this piece of the input data. When this kernel was overlaid on this piece, here, these first 3 and the first 3 rows and the first 3 columns, then I got this 4. When in the middle piece, I got the 3. How did I get the 4? 1 into 1 plus 0 into 0 plus 0 into 1 and so on. Do the math, add them up, there will be 4 ones where both matrices are 1 and that adds up to a 4. That's how the convolution operates. I'll have it more graphically displayed now. So why do I use kernels? What is this convolution kernel about? That's this. A kernel is designed in such a way that it keeps certain inputs in your input matrix and blanks out all the other inputs. Why does it do it? Remember, extraction. Now let's take a diagonal kernel. Look at that image carefully, and you see the diagonal kernel, as I move it or stride it over, and it shifts over the input matrix, okay? And as it shifts, you see the new diagonal has been created. So earlier it was this diagonal, now it is these diagonals. Now over a period of time, you take this input image and move the kernel over the image. So this movement is called a stride. The stride can be 1 unit, like here, it moved from here to here, 1 movement. Or the stride can be 2, 3, n units. You know, where n is the factorial the difference between the input matrix size and the kernel size. Now comes, what else is a stride? The stride can be downwards as well. So let's see the stride moving down. As I go through one layer, then I go through the next layer, and I can stride down by n number of levels like that. So this stride in turn gives me the final output matrix. Now observe the animation and you will understand convolution a little better. Clear what a convolution is? Okay, this is the secret operation. There is nothing more in a convolutional neural network. This is the only new operation that you need to know beyond to create that convolved feature. But how does a convolved feature even extract features? You've been saying kernels are about feature extraction. How does it evolve a feature? Here is how. So we saw what a diagonal matrix is. Likewise, I can create other kernels. Not just I need a diagonal kernel, I can create a left-edged kernel where only the left edge will get priority. I can create a news kernel. News kernel stands for north, south, east, west kernel. Only the north, south, east, and west. I can create a sharpened kernel. North, south, east, west with center having a negative value. What does this do? It sharpens edges of the input image. Like this, I can design different kernels, and the more the number of kernels, the more the number of features that you can extract. This is what happens when I do kernels. Remember, I taught a second operation. One, I was speaking about convolution we use. We also said we use pooling. But why pooling? And another aspect of kernels is about padding. So we use convolution with padding or convolution without padding. Why do I need padding? That's what I'm going to teach you. Earlier we discussed, if you remember here, there was this layer of zeros called padding. The kernel was moving only in the image data set. But if it moves that way, there is another problem. And the problem is the edge squares, these squares will actually get lesser weightages in the convolved matrix. Why? Again, basic mathematics. If you look at it, how many times will this part of the matrix get covered? Once, only once in this kernel overlap. When the kernel moves, okay, let's move the kernel. This will no longer be considered. So this came twice, this came thrice, and then it will all come thrice. This will come twice, this will come thrice. This came, oops. This came 4 times, this came 6 times, this came in 9 times. Now after this, it will all be 9s. But out here you see the edges are weakened. So that I don't weaken the edges, I need to start with a padding area of zeros. Zeros means nothing, no signal input to be taken from there. But because the kernel now starts from a further corner, these elements will, the edges will not get weakened, the boundaries will not get weakened. Now let's move that over that way. This is what padding does for me. Now you see I moved that matrix out so that after the padding, the matrices will have numbers like this. So you see this didn't get weakened into a 1 anymore. This is why we do padding. Padding may be used, padding may be skipped if you don't want the boundary features. Example, give me an example application where you're not interested in boundary. You have all those nice mobile apps where you take a nice click of yourself, but then you give only a focus. You give a halo around your head, or you give a circle, a rectangular border. You cut out the image's boundaries. There you don't need it. Don't use padding. But wherever you need to consider the edge features and the boundary features, you need to use padding. So whether you use it or not depends. But how will a kernel extract a feature? It is only extracting basic things like left boundary, right boundary, diagonals, news. But then how will it really extract feature? Let's compare. Let's take two A's written in two different ways because of somebody's handwriting, let's say. Now let's take the pixelation. In a simple pixelation matrix like this and like this, human eye knows both are A, but how do you teach a computer? Let's look at a simple 3x3 kernel, 3x3 kernel I'm using. Now, look at the 3x3 kernels on both sides. Are they equal? Yes, we all agree? They look equal or not? Only these two squares are black. So, okay, these are equal for now. Now, take the same 3x3 kernel in a different part. Let me move it by 2 stride. Stride 2 means 2 squares I moved. Let's move this by 2. Are they still equal? Yes, we all agree. Now let's look at the bottom element, the different part of the A. Are they equal? Clearly no. So this kernel in this position doesn't work. But let's see. Let's take a stride of 2. Let's take one more stride of 2. Now what? Now they're equal. You see, this is what happens in a convolution. If the images are nearly similar, when you take a kernel with a stride, some strides will match, some strides will not. But if they are generally similar images, many strides will match, some will not. This is how convolution extracts features and builds the intelligence into the network. Hey, these two images are possibly similar or possibly alike. So now, even the bottom two kernel extractions are equivalent. Now you can extract this. I know this is a great simplification, but you can extract this over several kernels, not one, not two. Let's take 64 kernels, each with different matrix combinations. Some with a left diagonal, some with a right diagonal, some with a left edge, right edge, bottom edge, top edge, news edges, sharpens. Now imagine what will happen. Multiple parts of the image will get feature extracted through the convolution. And clearly the convolution operation is reducing the dimensionality of the matrix. Let's see how it is reducing. So I took a 3x3 kernel on a 5x5 image, and you see the output is a 3x3. So image is this green box, kernel is the orange box, but what is the output size? It's 3x3. Did it reduce? Yes, it did. Now we will talk of the concept of channel. I told you, kernels are not just on one channel. Kernels are on as many channels as the number of colors you will choose. RGB, 3 channels, CMY, 3 channels, and so on. Now let's take color-wise channels. So I have a red channel. Okay, we've already seen this. We have a green channel. The same image seen in the green scale only will have a green kernel. The blue part of the image will have a blue kernel. I know the colors are a little bit hazy, but it's red, green, and blue. Okay. Now the 3 kernels and their individuals. Look at the image. This will now explain. I take 3 channels input. I take 3 kernels. I multiply them across the 3 color channels, and now I create the output. So how many output matrices will I get? 3. If 3 channels, 3. Assuming only one kernel I have taken. If I take multiple kernels, multiply 3 channels with the number of kernels. If I take 4 kernels, 3 channels, 12. The dimensionality output will be 12. But I should not have it that way. So what do? Across the channels, I take the convoluted numbers and I add them up. I use a summation function with a bias. Of course, there will be a bias. So that's kind of shown here. Look at this illustration. You will understand it. I'm going to just pause for 30 seconds. Have a good look. Make sense? Look at what's happening. The red kernel on the red channel, the green kernel on the green channel, the blue kernel on the blue channel, their output kernel channel matrices, add them up, add a bias, that gives you the output of the convolution feature. So I am extracting the input image features for a given kernel type across all the channels and then creating the output. Now going back to the initial problem, image matrix, convolution. But I have to reduce the dimensionality of the convolution matrix also. Imagine, I was taking simple examples of 5 cross 5 inputs, but we are dealing with 1280 by 1024 or whatever is your resolution is. The larger the resolution, the more. So if I have to reduce 1,000,000, I see some of you giving me feedback, thank you, and I apologize if I'm putting you to sleep. I know I'm acting like your mom, but here's a wake-up call for those of you. In case anything is unclear, please raise a hand, ask me questions. I'm good and happy to explain. All right, going back. So convolution pooling. How does pooling happen? We have dealt with convolution, we have dealt with padding, we have dealt with stride. But how does pooling happen? This is what pooling does. Pooling further reduces the dimensionality of the convolved matrix. A large convolved matrix is reduced to a smaller convolution matrix by pooling. Pooling takes groups of adjacency cells and reduces them to one number. Let's do 2 cross 2 pooling. 2 cross 2 pooling means I take these 2 cross 2 boxes and I am applying max pooling. What is max pooling? Across every 2 cross 2, 4 cells, take the largest number and keep it in the output matrix. So here the largest is 20, I keep 20. Here the largest is 112, I keep 112. 30, 30. 37, 37. This is called max pooling. But I need not do max pooling. I can also do min pooling, I can do average pooling. There are different techniques. Generally, max and average pooling are the norm. So here's the average pooling. It's the same, but now calculate averages of each of the 4 boxes. This way, I reduce the dimensionality of the output matrix. So 4 cross 4 becomes 2 cross 2 if I use a 2 cross 2 pooling. So now I need to see the whole thing in 3 dimensions. 3 dimensions, why? Depth of multiple channels, 3 color channels. So let's do that. So there is the input layer. I apply convolution. Convolution then creates my output matrix set. This is the output volume. The output volume will have one individual convolved output for each kernel that you use. So this is the convolved outputs. Now imagine that through all the layers of the convolution matrix of the input image. So you'll have multiple convolution volumes. Now each of these volumes will go through pooling, and pooling will further reduce them. Once they are reduced, the last operation is flatten. What's a flatten? All input matrices that have been achieved after the last pooling layer will be converted into a single vector. Simple vector translation. Just convert them into a vector. Why? Remember, your artificial neural networks input layer is always a vector. That is why I finally will go with the last option after pooling, which is flatten. Once I flatten them, these inputs can now go into your standard ANN, which you already know about. All of you, I'm assuming again, you know ANNs and you know how to optimize ANN. So I have reduced the dimensionality of the large input matrix into a simple vector with lesser number of nodes that then goes into the output. Now take a look at another math heavy slide, but yeah, that's the whole story. So simplifying the whole story, a 32 by 32 input becomes a 28 by 28 feature map, first feature map after the first convolution. Then with subsampling, subsampling is basically pooling. I reduce the dimensionality by 2, 28 by 2, 14. Why? Because I did 2 cross 2 pooling. So divide this number by this number. Then comes the next feature map, level 2, second layer. One more convolution, one more pooling, and then finally the last layer's feature maps are all flattened out. That gives you the fully connected layer. Simple formula, how do I reduce the dimensionality? I input matrix minus k, kernel size. Input matrix 5 cross 5, kernel is, let's say, 3 cross 3. So 5 minus 3, 2, divided by stride. Remember, stride can be 1, stride can be even 2, 3, 4, whatever. So you divide it by the stride and then add 1. That is the dimensionality of the output matrix. Pooling, just divide. Take this whole matrix, the output matrix, divide it by the pooling size. If the pool size is 2 cross 2, divided by 2. If it is 3 cross 3, divided by 3. That will be the final output size. So you see how the dimensionality reduced. If you understand this much mathematics, you know everything about all the advanced networks today. We'll see why. How much time do I have, ma'am? Huh? Sorry? Okay. Sorry. I'll try to reduce it 5 minutes more. Thanks. So now if you look at it, the significance of this whole thing is we started with some techniques we want to learn. How does the neural network actually learn those techniques is we take the image, the visible pixels are moved into the edge classification. I first do feature extraction, identify edges of the image, various different edges. Then the second hidden layer will identify little larger features, corners, contours. The next will possibly identify objects, the person, the background, and that in turn will help do the final classification. This is how standard neural networks in CNNs work, and these different layers correspond to those different aspects the way the human brain recognizes. This in turn creates a very wide complex of feature extractions. So here is a realistic feature extraction. You can see how layer 1 is very simple edges. Layer 2 has base features. Now let's go to layer 3. You see a little more complex features. This is a real input image. This is the third layer's output. Let's go to layer 4. Now you see in layer 4, we have now reasonable identification of the objects. Layer 5, human beings can't interpret them, but this goes into the sub-features, the contours and the textures of the objects. That in turn kind of summarizes how convolutions work. So I'm almost on the closer of time. I'm going to go a little fast through this, so pardon me for that. The slide will be available for you. So today's state of the art. In 2012, a research paper in the ILS VRC, it's one of the global conferences on visual recognition challenge, and this challenge was won by AlexNet. AlexNet is a specific network, convolutional network configuration that gave 85% accuracy for the first time. Earlier to that, percentages were very poor. And later on, based on AlexNet architecture, other deep architectures came in. VGGNet came in, LeNet by Google, GoogleNet, Inception network, Exception network. These are the more advanced networks that came in, and today ResNet kind of rules the tribe when it comes to classification algorithms. So what are these? This is AlexNet. I know it looks complex, but a very simple thing. Remember the convolution, remember the layers and the dimensionality reduction. That's what is happening here. From an input of 224 by 224 pixels, we're literally talking of a number larger than 40,000. I go down doing convolution pooling, convolution pooling, convolution pooling until, if you see, the last fully connected layer has only 2048 pixels. 40,000 to 2048. This is the beauty of how convolution works. I'm not going into the other mathematical details, but AlexNet used ReLU function instead of the tanh for the nonlinearity. It did optimization on multiple GPUs, graphical processing units. So if you see, this is one layer of GPU, this is another layer of GPU. And you can, the more the hardware you have at disposal, the more you can do it to optimize it further and sooner. It just makes the operation quicker. And it used a technique called overlapping pooling. So this kind of addresses what is called as overfitting, so that you don't have overfitting beyond the training data set. That's why AlexNet kind of gave a better resolution. That was followed by 2014 paper VGGNet. VGGNet has variants. The 16 variant and the 19 variant are the most popular variants. You can find about it more if you do your research. Just look up VGGNet, 19 layers, and I'll show you a picture of that. ResNet 2015 challenge winner. You see the number of layers has increased to 152 layers. This is what is deep about a deep network. Only thing is more and more layers, and the convolutions are of different sizes, not just 3 cross 3, 1 by 3, 3 cross 3, 1 by 3. This convolutional layers keep increasing till it goes to the last fully connected layer. That brings me to the close of the conversation here. I'll open up for maybe 2 questions at the most. I don't have time. So here is the efficiencies. You can see how the efficiencies improved over the years. Today we are talking about the advanced set of ResNet 34 and higher, and Inception Net version 3 and higher, Inception, Exception, and Inception version 4. These are some of the standards in terms of how many operations they do. You can see the operational simplification also that has happened over the years. Each circle's diameter represents how many million operations it did. The most accurate models today have come down. This is a representation of the VGG net layers, what I talked earlier, 16 layer, 19 layer. I'll not go into the details. I don't have the time for that. But you can meet offline if you're interested. So you see Google Net and ResNet today have excess of 152 layers. But look at the precision. The precision today is only 3.57 top 5 error rate. 3.57 is ResNet 15's error rate, which is better than a human being's. A human being has a number closer to 5. So if I give you millions of images and I say classify them, even you and I will go wrong. ResNet will go less wrong than us. That is what vision stands at today. Now, so what? We're discussing all of these advancements. So where is the takeaway for me, you and me? This is where it is. If you want to do this today, you don't have to do all that math and code all that algorithm. It comes ready-made to you and packaged. Here are some of the standard packages. You can use Python libraries like OpenCV, Keras, PyTorch, TensorFlow, FastAI. These are standard libraries where ready-made functions are available to do all of this for you. You just call conv2d, you just call pool functions, use it, pass your input channel in your input kernel and matrix, and you get the output. Custom models for VGG, LeanNet, GoogleNet, AlexNet, Inception are all open sourced. You can go look up their physical code and you can use those models if you choose to. Where can you do additional research? Better video stream analysis, I told you about this. Better traffic interpolation and action detection, intrusion detection, depth analysis, object simplification. These are areas of research for those of you who have a research bent of mind to explore further. And what tools do I have at my disposal? Many. I'm just going to list a few. And this is for students especially. You may not have hundreds of computers at your disposal. Use the cloud. And the cloud today has vision models. Pre-trained vision models that have been trained with not 10,000, not 50,000 images. Several billion images. Pre-trained models that have been trained on billions of images, so you get that whole intelligence readily available to you. Talk about data richness. The Google Vision API, you can visit that link and you can, if you have a student account, you can just freely access it. It can do everything from text conversions, classifications, and labeling. So here is Google's set of products, Vertex AI, where you want full control on your custom model. If you want that, you can use it. You can also use AutoML for partly pre-trained models, or you can build complete custom models using your Vertex AI. But if you want to use Google's models, you can use the Vision API. Vision API is a simple REST API. If you know how to code in any one of the popular languages, Python, Java, C#, you can directly use Vision API and you will get the benefit of those billions of images on which Google has trained its models. So those are some of the products you can directly use. Those of you who also know TensorFlow, you can write custom code in TensorFlow as well. Same with Microsoft Azure. Azure Cloud gives you so many of the various features that we talked about in Azure Vision Studio. I do have code examples, but I don't have time to go through them, so I'm skipping it. I would, at the outset, thank every one of you, both from the institutions, CVSR, particularly Dr. Vishnumurthy, if you're here around, and all the organizers. Awesome. I've been enjoying the conversations, and good luck to all of you paper authors and all of you students for your bright futures and your presentations. I would also like to thank and acknowledge the websites where you will find more information, like me. MNIST is the data set. Google and Azure Cloud Platform. Analytics Vidya, a good website where students can learn about various kinds of networks. Some of the research papers from where I pulled out some of the graphs. Of course, I thank God and Providence for having me here, and every one of you and the organizers for being a patient listener and giving me this opportunity. Good luck with all of you. Any questions, I'm open for 2 questions. Everything else we'll take offline. 2 questions at most. All right. I'm assuming. Yes, please. Yes, yes. Okay. The 2 kinds of human recognition things. One is human recognition based on physiology, thumb scans, retinal scans. There is possibility of similarity in thumb scans, but retinal scans, literally no. Literally no. But now comes the other algorithm that I was speaking about. In a stream of video, how do I detect is a human being doing a genuine thing versus is a human doing a wrong thing? Example, your CCTV video is seeing, let's say, a postman come in, trying to drop the letter, but the letterbox is sealed. So let's say he jumps the gate. Let's say he jumps the gate to come and drop it at your doorstep. It's a valid case of a human intrusion. Versus a thief jumping in your wall, how will the AI vision element or the algorithm detect this is a valid versus this is an invalid? And that is where I will say algorithms are not yet there for that. But here are some strategies. I'll give you some strategies. Simple common sense. How do you know this is a postman? Generally, the postman doesn't change every day. They are not strangers. They have been coming every day. So your CCTV can have a memory base and it can create those characteristic recognition of people that it knows versus people that it doesn't know. That is a clear-cut indication of who's a stranger doing an intrusion versus who's a genuine person doing intrusion. Now, a cousin that never visited you in the last 5 years suddenly visited one fine day and jumped your gate. And the alarm fires. Yes, wrong negatives will happen. You know, just like false positives are there, which is a part of accuracy calculation, and that's a known aspect of all AI. That's why we never say, if any company product comes and tells you I'm 100% learned network, they're lying. Plain blank, that's a lie. That's a white lie. It is possible to get X percentage of accuracy. Whenever it's commercially feasible, accept it. Not all intrusions can be detected by AI.
Like my problem is, I need to take attendance based on images of the students. So there are twins in my class.
Okay.
Is there a possibility that I can recognize both of them as a different persons or as the same person?
Twins will be biologically similar, visually, but not everything about twins are similar.
But
Facial recognition today can even identify difference between the angle of the eyebrows. Just the angle of the eyebrows is enough to distinguish two people. So twins also, for that matter. Second, very important, twins may be similar visually, but will they be similar semantically? What is semantics to a computer? Actions. Do everybody move their hands the same way? If every speaker were to move their hands the same way, you know how monotonous it can become. Same applies with twins. They have character. You can build models based on video stream analysis where you can look at what is called as behavior generalization. You observe the same person over a long period of time. If you give it a sufficient training data set, I can do behavior generalization. How does this twin write? How does that twin write? How does this twin walk around? Gait. You know how I walk? This way, some people will walk. You see, that's different. No twin will be alike in every way. So you have to look at those features, and the way you design your kernels for feature extraction, that will matter. And the inputs that you give in your input matrix, what goes into the input stream, that will have to change. Frankly, I don't have a single algorithm for it. There isn't an answer to it. But the answer is, you'll have to use multiple such algorithms and multiple new kernels to extract the essential features to distinguish these odd exceptional cases. It's possible. Thank you. Okay, I know I'm disturbing the organizers. Any further questions, we'll take it offline. Thank you very much for the opportunity, and I hand it over to the organizers.
Thank you, sir, for the detailed session on convolution neural networks and its applications. Now I request Dr. VVSS Balram, sir, to felicitate Mr. Anirban Pal, sir. And I request Sridevi ma'am to join.
I hope you found the session useful and enjoyable. And if not, brickbats, boquets, both are welcome. You can give me the feedback outside. Thank you. Thank you very much. Thank you, sir. Thank you. Ma'am, if you can please. Thank you. Thank you. Thank you all. Sure. Yes, you can, ma'am. Please.
delegates who registered for AML track, please remain here. Authors of the papers, please remain here. Those who are registered for AML track. Others can go to E102, 104, E104.
The students, we have the culturals after the paper sessions. You may stay back. Buses will be up to Uppal.
So the authors of A and ML track, please be ready for your presentation. A and ML track. First chance. Paper ID 9681. You're ready? Paper ID 630. Paper ID 4495 is there. 5946. 9182. Paper ID 9182. 6223. 51.
Hello.
Hello. Paper title start, sir. So good afternoon everyone present here. Myself Dr.
Yeah.
Good afternoon everyone. Myself Dr. Rajendra Prasad and my colleague Dr. Roshan Zamir Ahmed. We are from Ramaya Institute of Technology and Presidency University. We are presenting a paper on Braille's voice converter using image processing. These are the index which I will be discussing upon the abstract 9681.